we're going to talk about a concept of called mutation testing. Some of you might be familiar with the concept, some might have first time hear about it. So the agenda today is what is mutation testing? How does it work? What problems does it solve for me as a developer? And some best practices. At the end, we'll see a small Node.js project having mutation testing applied in there. Mutation testing, though, as a concept, can apply across all of technologies, Java, .NET, Node.js, JavaScript, everything. We're going to illustrate today in Node.js. I'm a Node.js developer, so I implement it there. So what is mutation testing? Mutation testing is a technique that is designed to measure the quality and the efficiency of your unit tests. So in other words, it will tell you how good your unit test suite is and how good of a job is doing to identify what problems your unit test detecting in your code, or because just because you have unit tests doesn't mean necessarily that you are covering those codes correctly or doing like the best part. You can have code coverage, it doesn't mean you could have a good unit test suite. And mutation testing considers the score of your unit test, how good of tests are. And so how does it work? First of all, the best news is there is no new code required for you to write. Different from functional testing, integration testing, unit test, you need to write actual code and spend a lot of time to write that code in order to get the benefits of that. Mutation testing, there is no code required. It's more like you configure your project to implement one of these. In our case, Node.js uses Striker.js framework. And the framework itself will do all the heavy lifting and all the work for us. And the way it does that is there's something called mutant. A mutant is a slightly different version of your code. And so the framework will change your code in a way that's going to try to break it. And then you're going to see what's going to happen. So, for example, you have a small function calculate sum of two numbers. It will take an input A and B, and then it will return A plus B. So mutant will say, OK, I see this line saying return A plus B. Let me try to create a mutant by saying return A minus B, A divided by B, A. So different ways to see what's going to happen. And then it does this for every single line of your code, literally every single line of your code in all possible combinations of mutation to see what's going to happen. And then when it does that, so it's created a long list of mutants, it runs your existing test suite. And you're going to say, OK, I made these changes, but do you have any tests in here that complained about this change? And as you can imagine, if you have a test that complained about the change, that's a good thing, meaning that I got that change that you tried to do in my code. In this language, you say the mutant was killed from your unit test. If a change was done and no unit test was able to detect that change, that means the mutant survived. Clearly, you have a gap in there. You either didn't write the test at all for that case, or the test that you wrote wasn't doing a very good job in that part. So I kind of talk about this. So after you run the test, you detect the problem and see what actions you need to take in there. So what problem does it solve for me as a developer? Like, it evaluates your test quality. Like we said, it's going to tell you exactly one step back. We as a developer used to say, oh, I had code coverage 100%, best case scenario, which rarely you see that, but let's say best case. And oh, I'm all good to go, nothing I can do more to make this code better. That's not 100% the case. Mutation testing is going to tell you, you do have 100% code coverage, but is the quality of your test good enough to be 100% assurance on your code? And what I mean by that is, so let's get, for instance, we have a function, very simple function that says, it's required, let's say, first line it says, if client ID is not defined, or user ID is not defined, throw an error. So we have two parameters checking on the same line. We have one unit test saying, call this function without a client ID. The test will fail, will catch the problem, will throw an error, which is expected, and you say you covered that line. So the line coverage shows covered. But you do not have a test case to say, how about if my user ID was missing? So in that case, your code coverage shows 100%, but when mutation testing come and update every line of every possible combination, we'll catch this case when you won't send a user ID, the mutant will survive, it will be marked as this case survived. And you know, oh, I see, I'm missing a validation for user ID. So this is an example where you have the code coverage 100%, but doesn't mean that your mutation score was 100%. And so it improves your code quality, and the idea is that when you run your mutation testing score, you'll see that some issues sometimes turn out that you identify a problem on your code and you update it based on that result, or you add more unit tests or coverages to make sure that your tests are testing the actual thing. So in a way, your end result, your code overall, is a better quality code. This is a big one. How many of you guys have been in a scenario where you say, I have this big part of the project, it's a legacy, something that it works fine, I don't want to touch it because it works, but I'm so afraid to refactor it because every time when you refactor something huge, you'll crash or throw some, not crash is the easiest thing, but like will create some bugs where you're not aware of it, and then you always are hesitant on that. Mutation testing will help you be more confident that if I change this code, if I refactor, I won't have any of these problems. And even though you might say, but I have unit test, again, 100% coverage, I'm more safe. Again, that's not the case, because during the refactoring, this is even a newer thing. For example, back to my previous example, if I have a function that says client ID and user ID are required, okay, I have two functions now, two test cases, just checking both of those cases where client missing, user ID missing. I'm 100% covered, and also mutation score is 100% at this moment. When I refactor my code, doesn't mean that if I had 20 functions, my previous version of the code, when I refactor, I still have 20 functions, exact same input, same output, same everything. So that's why you refactor. You merge functions together, you split more based on the code reusability, what's the purpose of your refactoring. So you might end up in a case where the same function that was before with these two params now has a third required param, let's say user type, where you pass this user ID, client ID, and user type, and based on that, the function returns admin user or regular user, some different logic. When you run your unit tests now, these two client and user are already testing their rule test, let's say all good. But guess what? You don't have a unit test for user type check, because that wasn't a thing on your previous version of the code. And you introduce a new case where you're not aware that this came across, because during the whole refactoring, you might have cases like this, a lot of them, so you'll miss some of them. But when I run my mutation test again, you will see that, my code was mutated with user type missing. It failed, telling me that this case is not covered yet. You add a new unit test, you run your again, and then you go to a point where now I have a 100% mutation score with a new code. I'm more confident that there is no bugs created on this version of my refactored code. So it's a really big help. And here in YAML, we implemented it in our team quite some projects, and we've seen this a lot of. I'm a person who I love refactoring. In my work, if I see some code that I don't like it, it bothers me until I find the time to do it. And I noticed that since I implemented mutation testing, it made my life a lot easier in terms of being confident that, hey, this is good. I back this code, so let's move forward. Some best practices. Just to add a little bit more to that part of refactoring, you can even do it granular. You can say, my project has, I don't know, thousands of lines of code. So, but my refactoring is only these 10 files. You can tell your mutation code test, don't check everything, because I might have some other place of the code that I'm not refactoring right now that have not 100% score. Only test these lines I changed, or these files I changed. For this one, I want a 100% score, otherwise I'm not gonna tolerate anything. You can do that granular check instead of having your whole project being tested just because you changed a section of your project. And that brings the best practice when I say mutation testing is a bit resource heavy. And what I mean by resource heavy is a small function returned sum of two numbers, it produced 4 mutants, like a plus b, a minus b, divided, multiplied, so 4 mutants for one line of code. Imagine a project where, projects I'm working on right now, there are like at least 6,000 to 10,000 lines of code across the whole project. So I expect at minimum 20,000 to 30,000 mutants created by that framework. So running for 20,000 mutants, running unit tests to compare if those are valid, it will take quite some time and quite some resources. So you start prioritizing and saying, I don't want to test every single line of my code. I'm pretty sure maybe 50% or 60% of your code is like core code, core logic, core business logic. Some of them might be some database initializations, could be some constant, could be some file that they don't necessarily need to be mutated to be like a test proven. So you can go as granular as you want, saying I want this file to be in my test, I want this folder or this line of the code, so you can go as granular as you want and you should do that in terms of rather than having a whole project, unless it's a relatively small project. Implement parallelization. A very good feature of mutation testing is that it allows you to run in parallel. So as long as you're processing power, so your machine is powerful enough, you can run 20, 50, 100 in parallel. So it'll take first 100 mutants, you'll mutate those, run the tests for you, and then take the next 100 and next 100, which makes a lot quicker the whole time running of the test. Set a threshold. It's similar to what we say about code coverage. Like, we know ideal is 100% code coverage, but who can achieve that? It's very hard to get 100% code coverage. So each company come up with a target. We say for my company works 90%, for some company work 95 or 90, or sometimes even for project like this project might be dealing with sales purchase. I want 99% code coverage because it's money involved. Some project could be something less important. You can say 90%. Same thing do with the mutation score as well. As good as to get 100% score, sometimes it's hard to get 100% score. So make a target and say, if my target is 90%, do not allow any new code coming to your project that is less than 90%, which will start, making your project more. And you can start. Some of the project when I first implemented, it was as low as 70% the score. Now I didn't make my target. I'm going to make this 100%, or as a team we're going to make this 100% next month. No, maybe next 3 months say from 70 to 80%, and the next 3 months from 80 to 90%. Because the score will mean it will give you literally a list of every single part of your code where you're missing a test or where you're missing something. So you can say, I'm going to pick the first, 50, and then process those tests next month, and then so on until you get to the bottom of the score or to the score where you are happy with. As you imagine, this can become part of your CI/CD pipeline integration. You can put it as part of every deployment you do, every push you do, that you can either be hard or soft, the way they use it, meaning you can say, if my new code doesn't have a 90%, which is my target score, fail the pipeline to let it continue, so you don't let the developer push it. Or you can be soft and say, just notify me or send a notification that this new code is below your target, but I'm gonna let the pipeline continue. You can be but making part of the integration, it helps a lot. So, see it in action. Like I said, I wanna run a small project, kind of see what we talked, what I said, kill a mutant, survive a mutant. How do I go about it? Like, I'm a developer right now, I'm getting a project, starting for the first time. How do I go about it in terms of fixing the score? So, you can still see the screen. Okay, so this is a very, very basic project. You cannot get any basic than this. So it has just some very simple function, get user, add user, delete user, and another function is format user. And I have a suite of tests. I'm going to run all the tests to make sure they all pass. You guys can see it, okay? So you see all tests passed. And then, okay, cool. How about coverage? I'm going to say npm run coverage. And I see, as you can see, I don't know, is it big enough or is it small? You guys see the letters? Okay. Okay, so we can see it's 100% code coverage. In normal world, I say, oh, this project, there's nothing to do with this because it cannot get any better. Well, I might prove you guys the opposite. So how about right now, let's say npm run mutation. Let's see the mutation score on this one. It's 65.8%. So you can be like, how can you be 100% code coverage and only 65% mutation score? It will list you exactly, it will tell you, we killed 27 mutants, but we have 14 that survived. So at least we have 14 cases that on that 3 functions in total that haven't been tested properly. It gives you this good breakdown here what happened, but it has even a nicer interface where in here on this folder report, this is an auto-generated file. So every time you run the report, it generates that file automatically. So nothing that you do special in there. And then you can open that in a browser mode, which it's a very nicer design. So you see this one, it says, I have only one file, users.js, but if you have more files in your project, you can list all of the files one by one, telling for each file how many survived. And if I click on the file, we have in here filters like show me all the ones, or I right now have it only the one that survived, because those aren't I care. The one that were killed, I was like, sure, test got that one. And look for these red dots. This red dot is telling me, before I even start, that this line of code was mutated in 2 ways, and the test failed to catch that way. So I say, okay, let me see how did you update it? Make me curious. And if you see the one in red, it says if ID is not defined, or name, or user type, one of them is not defined, throw an error because I need all 3 to be there. And the code changed to say, if ID and name are not defined, then throw me an error. Which means if one of them is not, code is not going to care. You say only if both of them are not defined. But that's not what we want as an application, and test didn't got that. I was like, okay, so right away I know that in my test, I'm not checking properly ID, name, and user type. I'm like, okay, let me go back to my project, and then I go to my unit test and say, what am I missing here? I'm pretty sure some use case in there. Now, as you can imagine, this is a demo, so I commented out intentionally these two tests that check the ID and the name. But if I bring them back and run the test again, we'll see right away a better score. Ideally, we should see a better score. So from 65, we see 70. OK. And then I can refresh this and open the new version of this report. And now on the new version, we should not see anymore the cases that we just covered. So when I go back in here, I see this line of code in here doesn't have any more any red dots because nothing survived anymore. And then I keep going down and down and say, OK, I see another function, format students. This function is designed to prove the point in here, but in theory, it's taking a first name, last name. It's taking a date of birth, major, and a score. Based on date of birth you pass, it's going to calculate what age is this student, and then also based on the score, it's going to pass if he has a passing or failing score. And we see that this first red dot in here is mutated to how? The code says get the year of the current year minus the birthday year, which is trying to get the year of the student, and the code is changed to say get the current year plus the year of the student, which definitely that's not going to give the year of the age. So, and I'm like, okay, so I might not have any test for age part. So when I go back to my test, I can go and see, okay, I see now that the developer who wrote this is only checking that the age is a number and is greater than 0. Well, that's not good enough. But guess what? That line in there made the code coverage to be 100% because the code had to go in there and check, is this a number? Is it greater than 0? Yes, it is. So move on, code coverage 100%. Well, it's not testing exactly what we should have been testing for. It's testing something slightly different. And then I do the math automatically, manually. So I see date of birth is this. OK, that guy should be 26-year-old. Let me add that 26-year-old and then run the test again. If I run the test again, it will see that it improved to 85%. So, and then you can go this same way of, and as long as, as far as you need to go, meaning what's your target? Are you trying to go 100% or are you trying to go at 90%? And when you reach your target, you can decide to say, these tests are or not important to me. So, for example, what I have left in here, I have left, OK, it looks like score is not being, status not being properly adjusted or taken into consideration. I can see first one is saying if score is true, then mean this function in this way will return always passing, and then it never failed. That means I'm not testing. I don't have a test case. From this I can tell I don't have a test case where score should be a failing score, because if I had a test that would test for a failing score, would have failed in here, saying you're passing true all the way. So I don't allow you that. And when I go back to the code again, similar concept, I see that I'm not even testing, checking at all for the status, so I need to bring that status back. And this is the way you would go about improving your code. I know that these are very elementary level of examples compared with real-world applications, but in real-world applications, actually they happen more. In here, it's very obvious that, oh, you're missing client ID or this in your test. So, but in a platform where, for example, again, my project where we're right now, there are literally about 15,000 lines of code unit tests. Being able to tell in there that I'm missing an edge case or I'm missing a test case without testing is very hard to verbally identify those problems. But this will tell you exactly these are the spots and all these lines of code where you're missing what you need. So this is the idea of mutation testing. I don't know if anyone, since we have probably another 5 minutes, if you have any questions or.
So guys, if you have questions, thank you for your talk. But
I just thought that's why I cut short a bit myself 5 minutes.
Okay.
If they have any questions, but.
Yeah. So the questions will have to be after.
Okay.
Make up for some time for the stream going.
Okay. Okay.
Yeah, all good.
Yep.
All right.
Yep. Of course.
Hello, everyone. Thank you all for joining my session. My name is Ramashankar Molleti. I've been working in this IT field for over a decade for now, working as a principal platform architect for options clearing, one of the stock clearing company. So today's topic, I'm going to talk about the convergence of AI, cybersecurity, and cloud technologies. Why this topic is important is because most of the organizations are adopting the AI techniques, and also the cybersecurity is most important for us to protect the data in the organizations. And the convergence of AI, cybersecurity, and cloud technologies are no longer silos. So I'm going to talk about that in detail, how that can be adapted, what's the best possible techniques you can use to build it, your system. So the new enterprise IT landscape, why convergence matters. As I mentioned, right, interconnected domains. So AI is not, AI, cybersecurity, cloud, they are no longer be a silos. They are not, they're always be connected each other. They should be connected each other. The reason why I'm talking about is, so you need to integrate, you need to protect the data, defend the data. Attackers coming into pictures, they would use several techniques to attack. It's a modern way of attacking techniques. I'll talk about those techniques in the next couple of minutes. So what it means is, in the organization, what we need to do is to make sure that all these systems combine together and build a unified solution to meet your organization goal, achieve the zero trust, like more secure platform, zero trust architecture platform. So as you can see, the organization's AI-powered attacks targeting cloud infrastructure. That's quite common. Everybody is using AI. People are talking about AI agents. A lot of AI agents, they are building it. Most of them, they don't understand how the machine learning, how the security attacks that's happening with the organization. How do you protect that from happening? How do you defend and then attack? In your systems, an organization has to maintain the defense and attack tools and the services that they're going to be so protective so that they can build their systems more secure. If any attackers comes in, you have the ability to stop them. I'll tell you about those techniques, a couple of them in the next slide. AI transforming cybersecurity, defense and offense. Both are needed. So AI-powered defense, you can see the automated threat detection and response. There are plenty of tools available to detect the technique. Let's say I would take an example of one of the cloud. I think most of them might have used AWS as one of those, right? So you can use, in AWS we have several threat detection tools available. You can protect the data, guardrails, guard duty, etc., and all those things, right? So, but they are not, they're probably a single cloud or multi. If you think about Azure, there is another way. If you think about GCP, there is another way. You think about on-prem, there's another way. It's difficult for getting all those tools together and then have them in a centralized place, right? That's a challenge for most of the organizations. How do you adapt the defense? So most of the attacks that's happening with I'll talk about the attacks. You can see that in the slide. So deepfake social engineering attack. What do you mean by deepfake? I'm CEO of AWS. They can create a fake video talking about, CEO is talking about some organizational changes everybody has to adopt. Oh, they will be sending a distributed emails or messages to all the individuals in your. So CEO had made this decision, so I need to do something. So it's a panic. So you would immediately react to those panics, right? Should not be reacting. One of the key factor I would think about it, like when you set up MFA, never ever use audio or video to set up MFA. So there are people who used to, I want to make myself not even in the systems that you are using, like cell phones and all. So you say that, okay, I'm going to use the audio. I'm not going to talk about the several other tools that are available, but never ever use that, because there's a way we can actually detect those and then take those voice and convert those voice in a way that, okay, this guy is speaking, but not really the guy who's speaking. Automated malware generation, it's been there for a long time. Malware attacks are quite common across the organizations. Adding those malware systems and automated those malware systems and injecting the malware to systems are quite common. Antiviruses and all this stuff. AI-driven reconciliation. This is one of the modern techniques that most of them. Manual reconciliation is very difficult to analyze, like web scraping the website, public data that you have posted across the platform about the organization, and they can use their different AI models, machine learning models, and the AI agents to detect and collect the information, more information about that, and then analyze those data to attack the systems. That's one of the ways. So when they are collecting this information, they have all the information about the company. So never ever put any of the public information or sensitive information in the public and allowing the attackers to use those information to attack your systems. That's one of the modern techniques, most of them using. So when you're building in your organization, you also build the same modern techniques to attack internally to see whether my system is defending. As you can see, the behavioral changes of the system. Talked about the differential in my slide. With the 25 minutes of time, I can't speak on how we can detect it. You can always reach out to me for more details how we can protect that from happening. I wanted to talk about another important factor is polymorphic attack vectors. What is meant by polymorphic attack vectors? So you build something, code, or develop something. You think that the code is working fine, and then you pretty much deployed and that's been available. So they can inject the code with some information of changing the signature and changing something. You don't even know that. Today, this code is working fine and everything is working fine, deployed, and then systems are working. Tomorrow, same code is behaving differently that you don't even know that. That's one of the technique, modern technique they can use. There are many models. I'm not going to talk about the models here. So what it happens is the attackers would use these techniques to attack your system. Most of the organization adopting AI and cloud technologies, almost everybody is using cloud in any organization. So attackers are very keen on getting those information to see how they can steal the data. So, if you have any organization do not want to tolerate losing their reputation or the data, you would have to pay billions or billions of money for that, right? So organization, especially for the finance sector, they got to be very careful of protecting those data, defending those data. You have to build internally these systems, defending attacks and then attacking techniques, so that you are protecting your systems by following this thing. So the digital transformation backbone, I collected from based on the data source. You can see that. That's data collected. So 94% of the enterprises now use cloud services in some capacity around. May not be full, but some capacity around. So, which is high. That means almost every company is using cloud, whether it is AWS, Google, or GCP, or Oracle. I'm not going to private cloud, whatever it is going to be. So, and some companies, they have the multi-cloud, and some companies hybrid cloud architecture. So multi-cloud strategy, 76% is attack surface growth has been increased for the past couple of years, 3.2 times. Then how do you make sure you can protect your sensitive information and data? That's that's important to understand. I'll talk about the framework that I have been suggesting to most of the customers. So what is the techniques you're going to use to build it? Rise of unified security platform. Why I'm saying unified means you have several integrated data flows. Some companies have APIs are integrated across several integrated data flows, and some companies have cloud native solutions, some companies have hybrid solutions. They have used some tools to protect or guardrail the data that they have in cloud versus the other systems. But all and all together, you do not have a unified solution. It's no longer be a single silo solution, because tomorrow it's going to change the world of having these systems integrated across the organization. So you have to build a unified security. I have thousands of tools available for building. For example, I can take a cloud native or a microservices, container security. There are several tools available. I don't want to talk about like SysD, etc., and all those tools. So similar tools does the same thing for others. It's not about tools. Reducing the tool set and implementing a centralized, unified security platforms are the paramount, so that you have one place where you can monitor your systems and also detect those systems, any fraud, fraudulent activities, things like that. So rise of unified security platforms has been evolving. Many of the organizations thinking towards how we can achieve that, and all the stuff happening. So as I talked about cybersecurity, SOC compliance, I can talk about the platforms like cybersecurity, data governance, cloud governance, and then AI tools, and the governance, all of them together. You need to protect those and create the unified tools. Reduce the tool sets to as much as less as you can. And the tools that you are bringing into your organization should be adapted, and make sure those tools are good enough to handle the security. Industry case study financial services collected from the, as you can see that at the bottom you can see I collected those information from publicly available. Leading financial institution implemented AI-driven security orchestration across their multi-cloud environment, reducing security incidents by 67%, improving response times from hours to minutes. So you have multiple tools. If you don't use those tools, obviously you tend to have those. Many of even cloud providers have made many mistakes. Most of the mistakes you see this configuration changes. You made a big mess of configuration that leads to big problems, right? You can see that in the online. There are several cloud events occurred due to those kind of things. So assessment, assess, and integration are the phases that we need to make sure how you can integrate, assess your organization goal, what your services you've been using, and come up with the plan. So this plan may not work for the other organization. It depends on your goals, your systems. It may not, but the technique, the flow and the technique would remains the same. The framework remains the same. So then, so this is one of the industry case, right? So most of the cases, critical challenges in convergence. So of course, yeah, I have everything combined together, but how do you maintain that? The risks, right? AI security risks, cloud misconfiguration, as I talked about, and the skills gap. So cybersecurity and AI skills are lagging. I know a lot of people are learning about what AI techniques, so AI systems, tools, etc., but not really the fact that those are really helping the organization on it. What is that, the use case that you're targeting? So I talked about polymorphic in the previous one of the attacks. Security risks that is in model poisoning and adversarial attacks. they can make your models changing, and your system thinks that it's working fine, but the behavioral it keeps changing to get your data out of it. Those behavioral changes, you've got to be careful and then protect and defend those information. So always have to see the patterns that's happening. And then you have the automated systems in place to detect this and remediate those problems. As soon as you see the behavior, block it. Then think about, okay, I see this behavior, I'm blocked immediately. So I want to see how do we protect this. It may be a good behavior, that changes made by the application that no one even aware of it, or it could be a wrong behavior. But defense, immediate defense, the system that you build, you can build an agent, you can build an agent. I'm not going to talk about the technique, I'm going to talk about how you can do it, what tools you're going to use, and depending on your organization. So obviously the skill gap, as I mentioned, AI expert shortage in security teams. AI, you can build the systems in AI, you brought the models. Let's say I'll talk about the anthropic models we have available in AI, like Cloudy and all, right? So dev spaces you're integrating with Cloudy and all, so you don't know what's happening behind the scene. You just use it, generates the code, wow, get my job done. But that's a developer thing. But how do you make sure that security knows that every single call you make the model is that secure, right? That's very important. So you build your defensive and attacking techniques within the organization to protect your data and any incidents from the security. Here is what I was talking about, strategic recommendations for enterprise success. Adopt zero trust architecture. I think you might have heard about zero trust in several places. So you should not trust any of the platform you build. Make sure that you have a proper security in place. Protocols are defined. You have encryptions are in place, and the accessibility are backed. Accessibility standards, role-based access models. There are plenty. I'm not talking about what you can bring. There are many ways to achieve that. Containers has its own security, container security, container detection, and container scanning, etc. Blah blah blah. So, but the adopting the zero trust architecture is most important, and consolidate security stack. As I told, I have the security stacks for the cloud that's being monitoring SIEM. Probably you guys have heard about that, most of the organizations. So basically it looks for the security events that's happening. So I can take an example of AWS Security Hub. This is one thing, right? So you monitor every event that's being collected and then take actions based on what's happening. But it's only for single. But how do you consolidate those security stacks in one place so that all systems are tracked in a proper way so that you can actually build the systems much better? Strengthen the vendor risk management, that's very important. AI governance, data governance, security posture, and compliance of all the cloud that you pick and choose. There are many AI service providers that think that, okay, I have this AI built out and I want to show that it's cool feature, it works really well, but it's a cool feature, but is it secure enough to use in our platform? How far you can use it, the boundaries that you need to set. If I'm developing something, I want to develop, but I should use those tools, but it has a way to get the sensitive information in the organization, then you should set a boundaries and zones, right? Split those boundaries only to the specific to that boundary. So protect those systems in a way. The strengthen the platforms. Obviously invest in talent, development, keep developing the stuff. You might be failing first time, second time, third time, and times, but you keep developing skills, keep developing the stuff that you are so interested in. So, at the same time, the technology is evolving. Today, I'm talking about AI everywhere. It is coming, like several people are talking about building the AI agents and all. Tomorrow they're going to talk about the quantum systems and all. 2030 you'll see those things. I'm going to talk about that in the next slide. Emerging technologies and compliance. Quantum computing, that's coming. And most of the big techs, every company being spending millions and billions of dollars on the quantum cryptography preparation. So that's going to be crucial for the systems. How do you, the large systems, so it's very large scale platforms. Nowadays, a couple of years, 20 years ago, small disk with 1 GB is like a big, it's a huge data that you can store. It's no longer be that case. Data is driven everywhere, you can store anywhere, and systems are in a way to process those data, so you have to build those systems. So we are going towards quantum computing and extended reality, new attack vectors in virtual environments. I talked about several AI attacks, how that's happening, what techniques they are using to build those things, and edge computing, distributed security challenge in network, periphery, things like that. Most of the key insights, as you can see on the slide, organizations proactively integrates AI-driven cybersecurity with cloud-native architecture, let's say 40%. That's the data I've collected. I also have done some analysis, research on different companies to see how they are doing versus what they are achieving overall. But still, there is a lot of gap here to improve. It's coming, and people are doing several POCs on the AI. We may not be successful at some point. We will see that in the next couple of years. There are many agents developing. If you go to any conference, they talk about some AI tools. So regulatory compliance landscape, building those rule sets to ensure that always mitigate the risk, always choose what the risk factor would look like. So let me tell you an example. So you can divide the risk into multiple phases. I cannot tolerate this risk. That means lock everything, don't do anything. I cannot tolerate it. I don't let the systems to do so. And then I have a medium toleration, that's fine. Then think about how far you can set the boundary for that. So many ways. Techniques, I can speak on those whenever I could, but yeah, feel free to reach out to me for those details. And enhancing data sovereign rules, right? So you have a classification of the data, whether the data is sensitive enough, business sensitive, or critical, or non-critical. You've got to classify and define those boundaries. Define those boundaries. It's very important. And EU AI Act implementation requirements are coming. I think it's a new landscape rules are defining 2025 and 26. That's a valid one. What it means is it creates the regulatory rules for the how the regulators think that, okay, this is the rule that I'm gonna, as I talked about, right? How do you protect? What is your sensitivity of that? And what tools you can go and use those. So that the governance, the rules you have to build, every organization has to build and restrict the rules. I can only tolerate this level, so I'm not able to make the system. So isolation and the protection and detection, and build your attacking techniques, not just looking for somebody attack and then take actions. Do a proactive action. My systems are good enough to defend the data that you think is sensitive enough. With that, I think there are embracing coverages for secure agile future, strategic vision, competitive advantage, continuous innovation. Let's lead this transformation confidently, securing today, innovating for tomorrow. Thank you very much.
there's a lot of excitement there. Okay. Hi everyone. Wow, I'm excited to be here at Commit Your Code 2025. I actually went to Commit Your Code last year, and it is what persuaded me to start applying to speak at conferences. And it's the first conference I was accepted to speak at. Of course, now this is like my 5th talk of this year so far, but it feels really special getting to speak here for you all at CYC. So let's get into it. Let's start off with a quick intro. So who am I? My name is Leah Thompson. When I'm not found glued to my laptop with an IDE open, I can be found hiking, reading, or cuddling with my dogs, aka my senior developers. And they are old, so it is a fitting title. I work as a DevRel engineer at Laravel. So what does that mean? It means that I am on the DevRel, aka the developer relations team at Laravel. So I interact a lot with the Laravel community. I also go to conferences and give talks. But I also do a lot of engineering work. So I build out the marketing websites for our products at Laravel, as well as any websites the DevRel team needs. So I worked on the blog, the community site that we have for Laravel that you can use to look for any meetups or conferences for Laravel, as well as, I'm going to go ahead and apologize, I'm saying Laravel a lot, but as well as Laravel Learn, which we launched last week, which is our learning platform. It has a PHP fundamentals course and a Laravel bootcamp on it. But my journey into tech isn't the traditional one. I do not have a bachelor's of science in computer science. I actually majored in mathematics. So I worked as a high school geometry teacher for a year and a half before switching into tech. And whenever I got into tech, I didn't even start with PHP or a back-end focused language. I started with JavaScript. So once I started getting into Laravel, which is a full stack framework for PHP, I started getting into PHP and Laravel last year. It made sense for me to leverage the React and JavaScript skills that I already had on the front end and pair that with the new skill I was trying to pick up of Laravel and PHP, which led me to start using the RILT stack. So that stands for React.js, Inertia.js, Laravel, and Tailwind. And then the graphic here are the logos for those technologies. So this kind of leads into our topic for today, which is Inertia.js, or more specifically, using React with Inertia.js and how it can speed up things on the front end. So that kind of leads us to the big question of what even is Inertia.js. So I would love to see a show of hands. Please raise your hand if you've never heard of Inertia.js or you've never used it. Okay. It was like slow at first. I just saw 3 and I was like, there's no way you've all used Inertia. Okay, so this is the perfect talk. So we're going to go over what Inertia is. But first we're going to take a tiny step back and talk about the pain points you might have encountered if, like the traditional way, if you want to use JavaScript on the front end, but you want to use a different technology such as Java on the back end, so Java and Spring Boot, or Ruby on Rails, or Laravel and PHP, of course. So traditionally, you would end up with 2 separate projects, 2 separate repositories, one for the front end and one for the back end, which leads to these kind of pain points. So on the front end, you would have to write your fetch or Axios request to get the data from your API and then show it on the front end. You would also have your use effect or state management, JSON parsing, client-side routing. You would have to deal with the CSRF token setup and then attaching that to your request. On the back end, you would end up with validation duplicated in the front and back end. So if you were doing error validation or form validation, you're going to do it in 2 different places. And you'd also have duplicate routes. So it's just a bunch of boilerplate code. You're copying a lot of the code. It's also, you're managing 2 separate applications. And that's where Inertia.js comes in. So Inertia.js gets rid of that problem. And it does that because it's a library that bridges your front and back end together. It does that by allowing you to write a monolith, and it removes a need for a separate API layer. So instead of having the 2 separate applications, everything lives in one application now. and you're not having to write all that boilerplate code. So to show of how you would implement this on the back end, this is a controller. So this is a Laravel controller. For Inertia.js, you do not have to use it with Laravel. The official package is maintained by Laravel now, but there are community adapters for other backend frameworks, such as Ruby on Rails, Spring and Java, Golang, Django. So you can use it with whatever backend framework you prefer. My examples are going to be using Laravel. So here we have a post controller. Inside of it, we have an index method, and we're just returning view of post.index. So this is a blade file, which is Laravel's templating language. So here we're just returning a front-end component. So this would be post.index.blade.php. That would be the file. But now if we want to change this to return a JavaScript or React component, this is all we would have to do using Inertia. This is all that would change. We're just having to bring Inertia in to our controller, and then instead of returning the blade view here, we're doing return Inertia render of post/index. So now this isn't a blade file. This would be our JSX or TSX file. And we just do Inertia render, and just like that, we're now using React. So this is how easy it is to bring Inertia in to the back end of things. But let's look at an example of bringing it into the front end and how it makes things a little bit easier using React. And let's do that by looking at an example of something that we as developers use all the time, which are forms. Okay, so we're going to do a coding demo. For this, I'm going to show the same form. So the same form with just a name, email, and message input. But we're going to look at the code 3 different ways. So a traditional HTML form, a traditional React form, so just bringing React in, and then using the Inertia.js form helper to kind of really show where Inertia.js shines and how it helps with the boilerplate code. So if we look at the code for just the HTML version, here we just have a form element like we'd expect. We have to set up a CSRF token because it's required for Laravel post requests. And then inside of this, we just have our input fields for the 3 inputs we want. So here we have an input field, type text for the name. This is a required field. We also have one for our email, which is also required, and then message, which is required as well. We only have one button here, so by default, this will submit the form whenever it's clicked, and that's it. So nice and clean, only 45 lines of code, but there's no dynamic state in here. We're not doing error validation, anything like that. This is just our simple HTML form. So now let's look at it, but with React. So already you can see this is way longer than the previous one, and it's getting kind of complex. We're bringing state in, so right away we have to import useState from React, and we're having to create all the state for our form data. So we have state here for the form data, which we are storing the dynamic data for our input fields in. So we have name, email, and message, which we are initializing to be empty strings. We're having to create state for errors, is submitting, and is submitted. Then we have a handle submit function we're having to create. Inside of this, if we are preventing the form from submitting on default, we're having to manually set the state for the different things, like set as submitting to true, initialize the errors to be empty, set as submitted to false. We're having to do our own client-side validation. So manual client-side validation if we want to have specific error messages for each field. So we don't get that out of the box. We're also having to set our errors if there are some. Then we have our try and catch where we're doing the fetch request to our contact route to be able to submit the data when the user submits the form. If the response isn't okay, then we have to set the error data. If it is, then we set submitted to true. It's a bunch of state here. We also have a function for handle change. In this, we're just using our set form data to make sure that as the user is entering their data to the input fields, it's dynamically updating. And then after 70 lines of code, we're finally at the form element. Here we're just using onSubmit is equal to handle submit that we set above. We have onChange equals to handle change. The value is equal to form data dot name, so the specific property field for on the form data, and we have that for all of our inputs. But here we do get some more, like we set up our own error validation, right? And we also have is submitted, so we know that if the form's submitted, then we can do some toast or whatever. But this is 115 lines of code, which maybe doesn't feel so bad, but if you're writing multiple forms a day or even a week, this adds up fast. Like you are doing a lot of boilerplate code that you don't need to do. So let's look at what the code would look like using Inertia.js's form helper. So already we got rid of the state. Now we're bringing in useForm from Inertia.js/React. And in here, instead of having to create my own state to hold the form data, instead I'm able to get data and set data from useForm, which useForm is the Inertia.js form helper. Do I need to zoom in more? Is this good? Okay. So data is what my dynamic data for the fields are going to live on. So here I'm initializing properties of name, email, message, and form type, and initializing them. Set data is what I'll use to dynamically update them later on in the field. We're also able to get a post object from useForm. So here in our handle submit function, look how much shorter that is. We're not having to do a fetch or Axios request. Instead, we're able to just use the post object that we're getting from the Inertia.js form helper, pass that the route, which is /contact, and then we can set an onSuccess function, and in this, we are going to reset all of the fields for the form after it's submitted, and reset as well comes directly from the Inertia.js form helper. So I'm not having to deal with any of that myself. We're also able to get processing errors and recently successful from the form helper. And errors here, before where we were having to do our own manual client-side validation for the errors, this is happening on the server side. So this is happening on your Laravel controller or whatever backend framework you're using. You don't have to deal with any of that on the front end. Inertia.js exposes it to your front end component. So if we scroll down now, in our form element, we have onSubmit equals our handle submit. OnChange, we're using set data that we got from the Inertia.js form helper. And then we're just using the errors that came from the server-side validation. And recently successful is what we're able to use now instead of having to create our own is submitted property to know if the button was submitted to show the toast. Now we're at 40-something lines of code. This looks way cleaner than what we had before, right? Well, what if I told you it could be even shorter? And I promise it's not the like, what if we optimize more when you shouldn't? This is a good one. So as of 3 to 4 weeks ago, Inertia.js now has a form component. And the form component allows us to use syntax that is closer to I lost where my form was, but that is closer to the HTML form. So I'm going to go up here, I'm going to remove useForm, and I'm going to change it to form. I can get rid of up here where we were getting data, set data, all of that from useForm, as well as our handle submit. We don't need that anymore. Here, we will get rid of this, and instead, same syntax as the regular HTML form. So we have action is the route we want to submit our form to. So /contact, the method is post. Let me go ahead and bring in some of this extra stuff. So I'm destructuring the object, bringing in the extra things I want from the form. I'm not using it recently successful right now. I'm going to remove this one. And then for all of the input fields, we just need to remove this part. So we just need to remove our on-change and value for each of these fields. And if we go to it, our form still works as expected. Yeah, did not break the live coding, we did it. And instead of 40-something lines of code, we are now at 22 lines of code, and that's it. Which if you look back at this one, which would you prefer? But this is kind of where Inertia.js shines and how it gets rid of a lot of boilerplate code. But let's think of some considerations or reasons people might be kind of concerned about using Inertia.js, especially in production. So I think a lot of people, when you talk about using a JavaScript framework on the front end, they think about SEO because they generally use client-side rendering. But Inertia.js offers an Inertia SSR, which is Inertia server-side rendering, right out of the box. And with Inertia SSR, it will pre-render the HTML, so when the user requests the page, it will deliver them the full HTML, which optimizes it for search engines. Now you might be thinking like, okay, that's great, but how hard is it to set that up in production? And honestly, it's never been easier. If you are using this with a Laravel backend, Laravel Cloud and Laravel Forge, which are two ways to deploy your Laravel applications, make it as easy as just hitting a toggle to enable Inertia server-side rendering on your server. And then to set it up locally, all you have to do are run these two terminal commands, and you have Inertia server-side rendering set up locally. And this is if you're using the Laravel 12 starter kits. So there's a starter kit for Vue and for React. If you use either of those, you just run these two commands, and you have Inertia server-side rendering set up locally. So that's SEO. But let's talk about scalability. A lot of people wonder, does Inertia.js scale? Like, what production apps are using it? Do they get like 1 to 2,000 concurrent users? What does that look like? And the answer is yes. So, of course, we use Inertia.js internally at Laravel. We're going to practice what we preach. If we want you to use Inertia.js, we're going to use it. So for Laravel Cloud, which is the top box here, we use Inertia.js with React. We use it for Cloud and for Nightwatch, which is the bottom product. For Laravel Cloud, in the past 30 days, there have been 13 million requests. And for Laravel Nightwatch, which is the bottom box, there have been 3 million requests in the past 30 days. We're using React and Inertia for these applications. They've been able to handle that many requests, not have any bottlenecking, and I think that is a pretty good example of being able to use Inertia.js and the scalability of it. Of course, there were also features released in Inertia version 2 earlier this year that makes that possible as well, if you want to dive more into that in the Inertia.js docs. And then the last consideration is, okay, that's great. We've reduced a lot of boilerplate code, but what about types? Like, I don't want to have to use PHP on the back end, TypeScript on the front end, and have to manage types in 2 places, especially if I have to create some of my own manual types to really work with Inertia.js. And that is where Laravel Wayfinder comes in. So this would be specifically for Laravel. It is something that is being worked on currently because we're trying to find a way to really optimize the experience of using PHP on the back end and React or Vue on the front end, because you can use Vue with Inertia.js as well. We want to make it so that you can write your types in PHP. That's your source of truth. And then on the TypeScript side, you just use those types. You already have them. They're pre-generated. You're not having to worry about manage the types in 2 different places. You update it in the PHP file, you're done. And Laravel Wayfinder is the new package we're creating to do that, which it will be going into public beta this fall, so very soon, and it will be at version 1.0. So that's a quick glimpse of kind of into what Wayfinder is going to do. And I love it because it shows where this whole ecosystem is heading. So today I focus more on React and Inertia, but the bigger story is that Laravel keeps getting its tools that make front-end and back-end feel like one seamless experience. And I hope you all enjoyed it. Questions? I'll move. Okay.
All right, so welcome to this talk about how interaction between applications can hurt performance in your systems and what we can do to mitigate that and get better performance. So I'm going to start with this. You might be familiar with these types of surveys. This one was published by Datadog, where they asked Datadog customers how much CPU do containers that they provision actually use, right, out of the requests. And they showed that a lot of the containers we run at very low utilization, right? Like more than half of the containers run at a lot less than their half of their requested CPU. And so, we're a big enough crowd here that I want to run a small survey. Can you please raise your hand if you know what the average CPU utilization in a production cluster is? Usually like a small proportion. So only 2, not a big sample size. So I'm going to skip. Do you want to just shout out what your average CPU utilization in the production cluster is, or? Right? Right. So yeah, I started 20, and yeah, 20 to 40% is the results are the results that I hear, mostly with very few people say above 50. It's really hard to get that much. If you look at what the hyperscalers, like the large companies that have tons of engineering power to optimize their deployments, what they claim they do, it's between 20 and 40%. But what happened over the last 2 years is that some companies have been able to achieve a lot higher than the 20 to 40%. So Google was around 35% in 2011, and it rose to around 50% in 2019, which is kind of amazing. It's 1.5 times more in a big company like Google. So what happened, if you look in publications that they've had, you can find 2 major causes. At least I was able to find those. One are advancements in vertical autoscaling. So that means choosing exactly the right CPU and memory requests for each pod so they can bin pack a lot more containers into the same number of servers. And as a community, the Kubernetes community has access to these types of systems with horizontal, vertical autoscaling and things like Castanai and Perfect Scale, and there's a bunch of other companies. But you need another piece in order to make this actually work, which is mitigating the performance contention between container that results, right? Like you're packing all these applications in, now they're starting to fight for resources and their performance degrades, so you really need to handle this. And this is what we're talking about in this talk. And so, we said that some companies have had the ability to have much higher utilization. It's not a secret how they do it. There's been dozens of papers over the last 15 years explaining what noisy neighbors are and how to mitigate them. And I think there's enough out there these days that as a community we can build solutions that are general purpose that we can use across the community to improve performance for our users and get higher utilization. And that's why I'm here. So I want to, in this talk, to cover what is the memory and cache noisy neighbor, and do I actually have it in my system? Then talk about, do I really need to solve it? Does it matter? Then talk about what are the potential solutions that we can build and what we're doing in the open source community. So let's go do it. I did my PhD in noisy neighbor mitigation, specifically network noisy neighbor mitigation. I then started a company that built eDPF-based network monitoring tools, which we sold to Splunk, and I'm a maintainer on the OpenTelemetry network collector, which we contributed, and I'm now working on noisy neighbor mitigation. Okay, so what is cache and memory noisy neighbor? So generally, what is noisy neighbor? We have applications that run on these physical servers. We like to think about them as running in the cloud, but actually there's physical hardware that they use. And they have to share the resources that are offered by the servers. When one application, right, like in the one in orange in this slide, uses a lot more than its fair share, then other applications cannot reach that resource, so their performance degrades, and that's noisy neighbor. And in this talk, I'm going to discuss these two resources, the cache and memory bandwidth. Cache is the CPU, the memory that's on the CPU. So how does a cache noisy neighbor look like? Usually when you have your application, it fits into the different areas of the cache hierarchy like this. You might have in purple is your blazing hot working set, is the memory that your application uses the most. That fits into L1. And then you have the hot, warm, and cool working sets that fit into L2, L3, and DRAM. When you have a noisy neighbor running next to your application, the noisy neighbor reads memory very aggressively, so it evicts your application out of the shared caches, the L3 caches, and now your application has to access DRAM for its warm working set, which is slower. In the more extreme case of a noisy neighbor, you have the noisy neighbor running in the logical CPU core, the hyperthread right next to your workload. And so it might evict your application from the other levels of the cache, L1 and L2. Sorry, I don't have a box there. So it evicts you from others, and then your application has to go to DRAM for basically all of its memory, right, in the most extreme case. So this can be a lot slower, right? Like L2 to DRAM is 50 times slower. So theoretically, your applications could slow down a lot. Do they do it in practice? It turns out, yes. Google ran this experiment with their production workloads, where they ran some of their production systems with these noise generators, with DRAM and cache. And what they found is for web search, which is the Google search node, there's a 5 times degradation slowdown when faced with a noisy neighbor. 5 times for ML cluster, which is one of their online machine learning text classification systems, and up to 14 times in memkeyval, which is a in-memory key value store like memcache. So this actually can hurt production workloads. Now, these noise generators are very persistent. They look like big data analytics, right? Like they run very aggressively all the time, which is part of the reason why we don't run big data analytics next to our interactive workloads, right? But does this happen with interactive workloads as well? It turns out the answer is yes. So in this experiment, MIT researchers ran a garbage collected workload next to memcache. And you can see on the top graph, you have the memory bandwidth on the system. It's very low while running the experiment, but as the mark phase of the garbage collector starts, the garbage collected workload starts, the memory bandwidth spikes up a lot, right? Basically saturating. And if you look at the latency of memcache, usually it's very low, around 50 microseconds, P99.9, so very reliably low. But then during the mark phase of the garbage collected workload, its latency spikes up. And this is like 3 orders of magnitude, 1,000 times slower for memcache. So even a garbage collected workload can cause this type of noisy neighbor. And if you have applications that suddenly read and write a lot of memory, they could be noisy neighbors to other applications. So to see how this might work on a Kubernetes cluster, we wanted kind of less of a synthetic experiment. It's still a benchmark, but we wanted to run a system with many components and see how they interact. We ran the OpenTelemetry demo, which we chose because it has around 20 microservices written in 13 different languages, which is the color scale here. And it simulates an e-commerce application. You have, I think it's a telescope shop, right? Like, and this is what you see when you go to your observability vendors, right? They demo with this system. And so we measured this metric, which is very common in papers. It's called CPI, which is the ratio of the cycles it takes a piece of code to execute divided by the number of instructions. And the idea is this. Your program is executing some number of instructions to service a user request. If there's a lot of memory contention, a lot of interference, then it's not going to be able to read from caches. It has to access DRAM, so it takes many cycles to execute that number of instructions. And if there's less contention, then it can access cache. It's a lot faster, then it doesn't take as many cycles. Here, cycles is like a measure of time. Right? And so what we found on the OpenTelemetry demo is that most services experience around a 20 to 30% slowdown when there's high memory contention. So the top 5%, the 95th percentile memory contention versus the median. Most applications are around 20 to 30% slower, with some applications suffering up to 3 times slowdown. So this actually happens in Kubernetes clusters. Okay, so should we actually do this? Should we try to solve this or not? Should we care? Well, think about it this way. We've been programmed. Here are 2 simulated systems, one with low load and another one with high load, right? And you can see this is the memory bandwidth, and you can see the spikes that you'd have from something like a garbage collector, right? And very intuitively, the high load system is going to have worse performance, right? Because you have these saturation events that cause a degradation, a slowdown in the other applications. So the more load you have on the system, the worse your 95th percentile, 99th percentile is going to be. And as operators, we've been programmed, we have it very ingrained. When we see bad performance, bad P95, P99, we immediately, what do? We scale out the system, right? Like we run on more replicas. So we move from the high load to the low load system, right? That's what we do. So let me tell it another way. There's high load on the system. That causes this memory contention, which reduces the CPU efficiency because now applications can't go to caches, which causes us to breach our SLOs. How do we fix it? We scale out. We reduce the load. And I think this is wrong. This is an anti-pattern. We shouldn't do it because it causes us to be inefficient, and it's not effective at mitigating all of the latency. It pushes us to a better place, but it doesn't really solve the problem. What we really want to do is to mitigate the contention between applications. And that would allow us to get higher CPU efficiency and higher load. And this is what the hyperscalers did, basically some of them, to get better performance. So if they can do it, why can't everybody have this type of high utilization, good performance? And just as another note, right, like we have these 2 systems. When we go from the high load to the low load, right, like we're pushing the latency, we're reducing the percentile latency lower, right? Like if we had high P95 percentile latency, we scaled out a little bit, the P95 decreased. But what about the P96, right? Like if we don't solve this, somebody's going to hurt, right? Like we can actually improve quality of life for our users if we solve this problem. Okay, so what can we do? Well, first thing, if we can only have observability and can only find the small number of pods that are really being noisy neighbor, there are some things we can do just by knowing what those pods are. First, we can adjust resources. It turns out if you try to squeeze down a garbage collected workload, squeeze down its memory footprint a lot, then its heap becomes very small, and now it has to do very frequent garbage collections. So just by increasing the memory that you allocate to that process, you decrease the frequency of garbage collection so you can become more efficient. Another thing you can do is you can go to developers and ask, your system is misbehaving, right? Like maybe it has a memory scan instead of using a hash table. Can you fix that, right? Like there's these patterns that cause high memory churn that are acceptable usually, but maybe not in, if it reaches the state where it hurts other components of the system, you can have this conversation. And as a final resort, you can always isolate the misbehaving workloads to their own servers so that they don't interfere with everybody else. So at least most of the services run well. And so even if you just have observability, there's a lot you can do to mitigate this type of noisy neighbor. But I'm excited about automatic mitigation, where CPUs today have support to directly limit the amount of cache and memory bandwidth that each application can use. That's awesome, right? Like, so we can just, if you have a noisy neighbor, you can just tell the CPU, don't let it consume all of the cache from all the other processes. And even if your CPU doesn't support it, like older CPUs and lower end CPUs, there's a lot you can do. For example, you can pin an offending workload to a core. You can tell it, you only run on this core and you reduce the frequency of this core, so you slow it down. So you don't have to have, you know, if you have a garbage collecting thread, it doesn't have to finish in 100 milliseconds if it's then going to be idle for 3 seconds, right? Like, let it take 3 seconds, but be very gentle on the system. I get this question a lot, like, shouldn't containers take care of this for us, right? You know, containers contain. Well, it turns out they don't. We haven't built that yet. But there is a subsystem of the Linux kernel that supports this called resource control. And you can build on top of that, and that's, you know, what we're aiming for. Great, so how would you build an automatic system to mitigate noisy neighbor? You monitor, find applications who are using more than their fair share, and then throttle them down. So you put them in a sandbox that can only use 20% of cache, let's call it, instead of 100% of cache. And both Google and Alibaba Cloud have published papers that they have systems like that. So Google has been using a system using CPI, which I introduced earlier, since at least 2013 on their shared clusters. And Alibaba published in 2020 that they had been using this type of system for over 2 years on more than 1 million cores. Now the problem is that applications change their memory patterns very quickly. So if you think about garbage collection typically takes between 1 millisecond and 100 milliseconds. Here you get these two graphs of the same system, one at of memory bandwidth utilization, one at 10 millisecond granularity on the top, and the bottom is the same data at 1 second granularity. And you can see that the top graph just has no signal. You just don't know who is the noisy neighbor. You just can't see it, right? Because things change too quickly. And so you really need to have very frequent measurements in order to discover noisy neighbor, which is very different from other methods of observability where you measure, you know, you get these data points once every minute, right? Maybe 15 seconds. Here we're talking about 1 millisecond. So we set out to build something that would allow observability at 1 millisecond granularity. So let's talk about what we're building. So we want to measure every millisecond. You want to get this measurement on all of the cores, how much memory bandwidth each process running on that core is using every millisecond. So you want to sample. The problem is you want to have very tight measurements, but what actually you're getting is some jitter, right? Like how, you know, you have these measurements, how do you make them really precise, right? Like you're fighting against this jitter in measurement. Because if you're trying to get 1 millisecond interval and one of them are, some of them are shifted 1 millisecond here and 1 millisecond there and another is just 2 milliseconds long, like how does that data make sense? How can you read that? And so we've built using eBPF and high resolution, and the kernel's high resolution timers, we built these synchronized timers where they tick every millisecond on every core. And we measured the difference between the fastest core to tick and the slowest core to tick. And you can get pretty good. This is like an Amazon machine with 96 cores. You can get it pretty tight, like most of the measurements under 10 microseconds jitter. So this is actually plausible. You can actually build a system with this. And so we did. And so this is how that OpenTelemetry demo looks like, the cache misses in 1 millisecond granularity. So this is half a second of the run. And the colors here are the different processes running on the system. And here you can see an anomaly, right? So the OpenTelemetry collector, there's a 30 milliseconds there where it has a lot of cache misses, more than the ordinary. Now, if I move that graph to the top here, And on the bottom, I'll plot the cache references. So this is the memory that doesn't hit, that is able to hit cache. You can see that there's a decrease around the same time, right? So that amount of memory misses looks like it evicted other applications from the cache, and they were not able to hit the cache. And so the overall throughput for the memory hierarchy decreased. This is like the slowdown, right? You can actually see it here. Right now, we're in the phase where we're getting these 1 millisecond measurements, and we're building these detection mechanisms that using these 1 millisecond measurements can tell you, okay, now this application is being noisy neighbor, now that application is being noisy neighbor. And what you could do with it is you can get this type of observability of, here, this application is being noisy neighbor 2.2% of the time, or 0.1% of the time. So you can see which of your applications are hurting performance for others. And I'm really excited towards the possibility of, getting there where you can do automatic mitigation. Now that you have these signals, this is being a noisy neighbor or that, to move it into a system, like I mentioned earlier, where you can actually go and throttle the offending application. We put a lot of effort into making the collector itself be low overhead, right? Like you're collecting measurements at 1 millisecond granularity that it could take a lot of CPU and memory to get these buffers and flush them out. So memory utilization, we benchmarked it under 350 megabytes, even on a system with 96 cores. And the CPU utilization increases with the amount of workload. The more applications use memory, the more they context switch, so you have to account for which application is using how much memory bandwidth. So there's an increase, the more in the red on the bottom is how much utilization the application had, and it reaches 30 cores, 30,000 millicores. And in blue on the top is how much the collector took, which rises towards like 200 millicores. So that's 0.75% CPU overhead. So bottom line, 0.75% CPU overhead. But I want to make the point that even if that CPU overhead was 5 times larger, right? Like if it was 5%, so then it would still be okay as long as it would help you mitigate noisy neighbor. So let me give you an example, right? Let's say you have a system with 40 milliseconds median, average utilization, whatever you want to measure, and then P95 of 250 milliseconds. If I could decrease your P95 from 250 milliseconds to 75 milliseconds by reducing noisy neighbor, and you'd have to pay 5% in the average, so increase the average from 40 to 42 milliseconds, I think many operators, many people would just say, like, yes, let's do this. This is completely worth it, right? Like predictability matters. And so I think like 5% is way overdoing it. Like the overhead is not going to be 5%. We're already reached like 0.75%. But even if it was higher, you'd still want to do it. If you want to deploy it, the Helm chart's available. There's documentation. There are scripts to plot the results. And I'm happy to help you out. I'm actually looking for kind of early users who might want to see how their systems behave, and I'll work with you to make sure that your side project is successful, or your project. Okay, so my contact details are on the repo. This is the repo. It's open source under an Apache 2 license, so you're welcome to use it and contribute to it. And I'd really love to invite you to contribute. The project itself is written in Rust and eDPF, if you want to try to dabble in that. But we're also looking for contributions in these benchmarks and stress tests, and some data analysis to, from the 1 millisecond granularity data, extract noisy neighbors. And if you want to run the collector, we'd love to help you so that we know that it works for a large community of people, that, to iron out all the kinks. And hopefully this will help everybody get to the higher utilization, reduce, save some money, and also improve performance for users, so that we're not in this, like, this is fine, everything's burning, everything's noisy around us. So with that, thank you, and I'll be available outside for questions.
Ha. Okay. Yeah. All right. No. Whatever. All my wonderful words have been wasted on the internet. All right. I will go talk about this real quick then. Stop hitting yourself. You know, everyone causes themselves. We're not paying attention. We're not doing the right things. We hit each other. I'm not going to talk about me. The OWASP Top 10 is important. It's an open worldwide project, nonprofit, lots of people to donate their time to it. It's from big organizations to small. It's super important. You need to know it because these are what's going to happen with people attacking your applications. It's super important that you actually focus on these first before you go into the farther items. The biggest one they have right now, and I mentioned before that it was 2021 is the most recent one. It's not updated every year. They take surveys, records, everything, and they work together to compile a real list. So these are actually real security professionals doing this. This isn't like someone just saying, I think this is important. This is real stuff. Broken access control, again, to go quickly with it, this is where people can just get to things they're not supposed to. You need to make sure you're protecting this. It affects huge companies, small companies, all of it. From the overview, you can see it actually moved up from the 5th to be the 1st, and this is 2021, but 94% of applications were affected by this in some way, so out of 100, 6 were okay. That's a crazy number to have. And you need to stop letting yourself get hit by this. Make sure you're doing the right things. Don't let people that don't have access to it, don't have access to it. Check your ACLs. Check your items that are going to go through it, where you know people have it. Random IDs. Don't stick with table 1, 2, 3, 4, 5. Don't give that to a customer because they're going to be able to see through it. Have you ever gotten a PDF and said, this is number 37, what's 38? You've enumerated, and you can get to things you're not supposed to. That's broken access control. Cryptographic failures. This is kind of an interesting one too. You need to use strong hashes, and this is on you. Again, this is a big point about stop hitting yourself. You need to make sure that you're doing your work, your diligence to know what's acceptable. I guarantee if you work for a big company, they're going to have a list of cryptography that you're allowed to use. So it's important. You can see things like Marriott, databases, all were gone. We're encrypted. The encryption wasn't worth it. So it didn't matter that they encrypted. You have to follow the right information or you're going to have a problem. One thing I wanted to point out this one too with the OWASP, this actually ships up to number 2 from number 3, but you are going to see that some of these kind of change throughout the years. And if you go to the OWASP site, you're going to see they actually move around, they float, and you can see things. Again, cryptographic failures, make sure you're encrypting things, make sure you do the right encryption, and for the love of God, don't leave it there at the same place. You need to update your stuff. Injection, this is what everyone kind of talks about, like, I was able to get this, and it got in there. That made no sense, sorry. If you're able to put in stuff into a field, you need to make sure it's not susceptible to injection attacks. It's super simple to go in there and just say, well, this is a search box. It connects to a database somewhere, most likely. You need to protect your stuff. I put in the log for shell, but I don't know if anyone remembers Sony getting attacked from a database. Still good? Yeah. From a couple years ago with the Dictator movie or something like that. The one for North Korea. Anyways, but it affects everything from how you input is what it's going to attack. You need to make sure that you're using parameterized queries. That's a fancy term for saying that you just can't build a string and put it into your database. You need to make sure that what you're using is actually checked by the database, so they're not putting in extra characters. They're not escaping things that they don't expect. Sanitize all user input. You cannot trust the person. Anyone who's going to put something into your computer records could just attack you by accident. It doesn't happen on purpose sometimes. Maybe they have a cat that jumped on a apostrophe or a semicolon or something like that, and they broke it, and you're broken in production. It's not great. Don't be that person. Insecure design. Okay, this one is I love this analogy. Remember the story of the 3 little pigs? Skip the hay, skip the sticks, go straight to bricks. Okay, it doesn't matter if your lock is super fancy, even the best protection. If you can just walk through the side door, knock on through it. You need to make sure you are protecting your stuff. Use threat modeling to find flaws before you write the code. You need to do war scanning sessions, things like that. Build security from the start. Don't let this be something you don't think about. In the little example, they're talking about what it can do right here. You're not thinking about how you're requesting things, and you can charge it. A common thing is just when you're running something there, can you change a variable you give to the system? Is it expecting to trust the front end? Are you going to have a problem if you trust the user? And the answer is yes, because you can't trust the user. Security configuration. This is something that everyone's done when they're personal lives. You've moved into a house, you rent an apartment, change your locks, get new keys. Don't trust in the security that's happened by default. So many times people are going to go in there and just say, well, the default is the best one. Don't take the default. Every place from Java, the actual documentation has secure coding practices, to Amazon will have secure coding, not coding, but configuration policies. Follow what you need to do on this one, okay? Capital One, misconfigured a firewall, allowed an attacker to trick the server into making a request to an internal cloud metadata service. This is huge. Like we're talking about, like Capital One, millions of records could have been exposed. It's a big thing to be responsible for, okay? And if you're not taking care of it, you're not blocking things, what you're going to end up happening is letting attackers see what you don't want them to see. Harden your systems. Don't have extra features. If you're using a server and you're keeping it in a rack and you don't ever log into it, turn off the X11, turn off the windowing stuff. Don't give your errors out. I think this is a funny one. People love the verbose errors, and they're great for your logs. Don't send them to your customers. They don't need to know your database names. They don't need to know your table names. They need to know nothing like that. Because once you get the database and you can see things, you're going to be able to do a lot more with it. Just looking at, going back to injection, if you look at blind injection versus error injections, you're going to be able to see things. And you get that little breadcrumb and you get into it. And there's tools that automate tons of stuff now. With just one little error, they can start getting much more. Vulnerable components. Again, this is a fun one because it's just you're not updating. My favorite thing about this is you need to upgrade yourself. Oh, if you were still using Java 8 with Spring 4, you need to move. It is time. We are in 25, the year and the Java. So you got to move from it. You got to have things different. Don't use Struts 2 Core from 2015 or 14. Go to the new versions. Stay with the stuff that's relevant. Stay on security. Stay on the newer versions. If you can't be on the newest version, make sure you're staying on the maintained versions, like an LTS release of things. Don't get stuck in old versions because it always becomes harder to move. Just ask anyone going from 8 to 25 this year, and they're going to tell you that 9 jump was hard. All right. A real word one is Equifax. They're always in the news. But they're a funny one to have. Again, Apache Struts. It's an old framework then in 2017. Don't stay on it. Internal, external tools, you're going to get having problems if you just stay on these things. A07, identification authorization failures. I think I finally made time, so I'm going to slow down if I can. Don't allow password 123. Don't allow pin 1234. These are common things, Enforce strong passwords. You want to make sure that users aren't going to have to go out to, writing a piece of paper that's 3 pages long for a password, but I love XKCD's comment about it. It's horse battery staple that's been there for however long. That thing has 28 bits of entropy. That is what we're looking for. Strong passwords that are rememberable, that are memorable for the user, but not easily guessable. Give a couple words in there. Timeouts and lockouts, functionality MFA. I don't know if anyone remembers the whole issue with, I want to say Uber, but it's probably not. The MFA bombardment that happened to a user. They were getting pinged in the middle of the night, check your MFA, authorize, authorize, authorize. And they didn't do an account lockout. It's something you need to have. And they just pressed yes one time, and it let them get access into the system. Account lockout functionality is a big one. I know it's going to sound funny, but I remember working in a smaller IT shop years ago, and we were just in a little city in Alabama is where I was. And we had a Windows server, had an email domain, and someone just kept pinging us 1,000 times. The thing wasn't configured right, and it brought down that server to its knees. We had to cut it off the network just to get it properly back up. So make sure you're doing these things, Maybe 15, 20 years ago, no one thought about it, but it's super important now that you're locking your stuff down. Don't get stuff where you have an issue where people are able to access your stuff and you're just not monitoring it, okay? Software and data integrity failures, okay? If you remember SolarWinds, this one is 2020, it's funny timing. We had SolarWinds injected systems. It was a part of everyone's components and pipelines and all that. And it infected so many more systems because it was able to be part of everyone's systems. So when you get software updates, don't trust them. Microsoft has digital signatures that you can literally right-click and you can see them, okay? You can see who signed your binaries, you can see who signed the stuff. Make sure you're trusting the right people and not just downloading things off the internet. I know that Macs have gotten so ridiculous now where you have to accept, if you want to trust to download from a single website. It's an important thing to do because you need to make sure you're not causing yourself heartache in the future, because it'll get stuck in your systems. This is a bit of a tangent on this one, but Ken Thompson, Go and the Linux or Unix Ken Thompson, wrote a paper on the ability to trust a compiler like 50 years ago. And you can't trust it, because if they have access to your code and can compile your code and put into binaries, you are always going to be at some point susceptible to what's written for you. And so if you can't trust your tools and they inject things, you're going to be vulnerable. And so you need to make sure you can trust your tools. And this has been a long-running problem. In the example, again, this is deserializing data. Again, you can cause a lot of problems by just not checking the data if you have users entering things. And that's where a lot of stuff comes down to. It's not just trusting external vendors and targeting yourself from them. It's also trusting external users. Are you making sure that you have taken the steps proper to avoid having any user input? Because they're going to get you, and they really will. Let's see. Number 9, security logging and monitoring failures. Okay? It's a funny thing to have this one. If you're going to have logging, it's got to be good logging. What good does it do if you have a security guard up front and he's just drawing pictures of cats? You know, he doesn't mark down names. There's no man trap in the front. They're just playing around their phone. What are you doing with that? It doesn't help with security. It's all theater. And that's something with everything in here. Again, you've got to make sure that you're looking at these logs. It doesn't matter if you have a log if you're not paying attention to it. If you sit there with the logs, you're going to have so much data that you could use, but you aren't. This happened to Target. I remember like 10, 15 years ago, everyone had to get new information because Target systems were literally telling them, hey, you have something happening, all in their scenes. And they weren't paying attention. You have to know to look for this. And again, this is why I say stop hitting yourself. If you're writing this can't be a log that you just say, what's a CVE and I need to know about this. No, this is important stuff. Your application is going to be different from everybody else's. So you need to know what to look for in the logs. If you're building the application, make sure you're writing the logs. Do you expect to see things? Are you doing the proper statements? You know? Centralize and format. A lot of people have a lot of data. And I'm going in this one a lot because if you don't look at your logs and you don't look at the data, what good is to have the logs? You are going to end up with a situation where you're just like some other companies that have gotten into hot water and they didn't know they were hacked. And how long are you going to let a person to your system? Didn't we recently have the telephone networks infiltrated by other countries? Verizon, AT&T, didn't know how long it was. This is stuff that's happening to big companies that manage our infrastructure across the world. This isn't a small thing. You have state actors attacking your companies. So the last one I put on this one is server-side request forgeries, okay? SSRS, or server-side request forgeries, are a big fun one. So this is like having like a man in the middle. So what you'll have is you'll have like a user will request something to a web server, and they can just kind of smuggle in another request. If you've got your components set up in a way where you have a trusted zone and untrusted zone, you have to think about the trust on your own internal network. We cannot be, chocolate M&Ms. We need to be crunchy peanut M&Ms. Got to be hard on the outside and hard on the inside. So if you're stuck with that, that's how you need to think about this stuff. You can't trust things. Do not trust your own stuff to do the right things. Stop hitting yourself. Stop letting your own services, your own places in there attack your own internal network, because it can happen. Okay? We had the capital one again there. Validate all user-supplied URLs against an allow list. Don't use a blacklist. Use a whitelist. Okay? Because with these, what you can actually have is a problem where people are able to malform what you want. It's very funny. Or if you do nothing at evilcorp.com, well, what if you just put something behind it? It's still going to pass the filter, especially regex filters. You would have to know what you're searching for, why you're searching for it, and what you're doing with it. If you just say, I want these 3 websites, and it matches this perfectly, you're not going to have a problem. But that's the catch. We're not going to have perfect input. We have things that come from users. We know we can't trust it because we've already seen some of these other issues. But you know that when you get the data, you're not going to punish a user for typing in a capital versus a lowercase. I hope you wouldn't. That's just mean, And then deny by default firewall policies, okay? Deny by default is a strong practice, and it goes with everything, with all of these here. If you have a user trying to access anything from the first one for injection, for any of this stuff, deny it. You do not need to let your users have access to things they don't need, okay? Because what you're going to do is just leave yourself with more and more holes where you have problems at. Okay. So, you stopped hitting yourself, now what? Like toothpaste like this one. I don't know, I think it's funny when super issues random things, they're normal things. Okay, it's good to know that you've gotten like started, pat yourself in the back, but this isn't a one-time fix. It is a lifestyle change. It's like brushing your teeth. You don't do it once and call it a day for the rest of your life. You have to continuously move it forward towards the goals, okay? Be the roadrunner, not the coyote, okay? You gotta keep learning, okay? The coyote got there, stuck with Acme. He loved the company, great products, but unfortunately, they blow up in his face all the time. He ends up smashing half the stuff, okay? Be the roadrunner, always moving, always learning, never getting caught by a falling anvil. You've got to move forward. You've got to know where your goal is. You've got to look around you, okay? One of the best things that they have out there, which is free, is Portsmouth Web Security Academy. It's a fantastic, free, and interactive training ground. It's free. You'll get their tools for free. It's amazing. You should do it, okay? It'll give you the intros and all of it. Pay for the premium license, you'll actually get additional features like link you to documentations about theirs, help you with scannings, everything. OWASP is a great project, and you need to spend time with it. They not only have the cheat sheets, they have checklists and guides and everything. The cheat sheets are great if you're working with technology. Checklists help you go down like a pen tester would. Test your stuff first before you have someone else come in and get it. Great. Stop running a sprained ankle, use the tools. Again, we've got all these things out there. If you look at the tools for our development, you've got CI/CD pipelines. Do the stuff with the tool. Static analysis, dynamic analysis, and software composition analysis. You need things to scan your code. You need things to scan the dependencies. You need things to actually do it in production while it's running. You would run antivirus on your servers in most cases. You would run monitoring tools. You need to be doing it for your applications. It's not just monitoring performance. It needs to monitor your applications behaving properly. It's where logging and monitoring come in. It's where all of it comes in. Okay? And the next thing you can do is that get your team to help with this too. This is not something you can just say, oh, it's not my problem, I'm not going to do it. You can't throw it over a wall. You got to stay with it. With more and more things becoming security, more and more places become security conscious, you are more and more responsible for actually handling security yourself. And you are going to have to start with secure designs. Someone mentioned earlier in the talks about AI. You know, AI is great, but it's dumb. It's just a glorified autocomplete. It's a model, it's weight, it's numbers. It doesn't understand true contextuality. It's just what an autocomplete thinks it would want for the next number, okay? And so if you put things in there and someone writes it wrong, because let's face it, it's a lot of GitHub code, and I've written a lot of bad GitHub code. So it's still there, but you're going to have problems with it. So don't trust it. Don't trust the users. Don't trust the people. Don't trust anything else, okay? So you connect with me and find out more. Yeah. Oh, no one did it. Oh, darn it. See, I'm actually upset about this because I put this as a Rickroll. No one put other, do you see it? I'm glad you got it. This is really it. Sorry, but thanks. Remember to think securely. Don't trust me. I'm a troll. Everyone's a troll, and they will ruin your stuff.
Thank you. Thank you. Welcome. Welcome to my talk on first principles. This is something that I've wanted to talk about for many years, and finally got an opportunity to put together a little presentation here, talking about what first principles are, and at the end I'll give you an example of one of the first principles that I think is very important. So we're going to talk today quickly who I am. I'm going to give you a little disclaimer, and I'm going to talk about the different cognitive tools from first principles to heuristics, and then to a category it's called pro tips. And then, we'll talk a little bit about what I consider the most important first principle of software development, which is computers run code and humans read code. So who am I? I've been a professional software developer for 25 years, mostly server-side development, mostly in Java, some JavaScript. Work a lot on data transaction platforms, and I've become very good at tuning relational database for query performance. There'll be another opportunity to connect on LinkedIn. If you connect on LinkedIn, I'll accept. This is a little disclaimer. This is the first time I'm actually doing this presentation, so I'm not quite sure if this presentation will run fast or run slow. I'm not really sure what questions people might have. But these slides have a certain logical order to them. So if you have a question on one slide, chances are there'll be an answer on the following slide. If that doesn't happen, raise your hand, ask a question. Feel free to ask any questions you want. All right, so what are first principles? The first principles are, the truth, the whole truth, and nothing but the truth. The types of people that really focus on first principles and trying to understand them tend to be more experienced or senior in a particular problem. So we're talking about software development. So people that have been around software development for many years tend to think about first principles, and that'll become clear when we start to compare them with the other categories. If you understand the first principles of a problem, all other ideas and rules can be derived from those. It takes a lot of thought and reflection to come up with the first principles. So even though senior people may understand first principles very well of a problem, they're not thinking about them all the time because it's too slow to consider, what should I do here? How does it relate to the first principles? So we have other tools like the heuristics or the tips that can make you move quickly day to day. One of the hallmarks of a first principle is if you violate it, you're going to regret it. And sometimes you don't even know you're violating it, and then years later you're like, oh, why is everything so messed up? It's probably because you violated one of these rules. And how to think about first principles? You try to break everything down to the most basic components. So you just kind of keep asking why, until you try to hit the bottom. Where there are no more assumptions about a problem, and they're just these absolute, undeniable truths, or the core elements of the problem. And when you're coming up with the first principles, you have to challenge every solution that's out there, every idea that's out there, and kind of refuse this idea of, well, we do this way because that's how it's always been done. You tend to have to rebuild from scratch as opposed to taking what we know and then kind of iterating on it. It's better just to challenge everything, throw it away if you have to, and then build up fresh. So first principles are the bottom of the pyramid, and then the level that builds on first principles are heuristics. So they're the logical extensions of the truth. And people tend to be more intermediate when we start to think about heuristics, and they tend to think more in terms of these kind of broader concepts, but not quite first principle level. These are good rules that you shouldn't violate unless you have a good reason to, and then you can. But you should know what you're doing before you start to, well, we don't have to follow these heuristics for whatever reason. And intermediate developers start to learn these before they really start to dive into first principles. The level after heuristics, I just call like pro tips. So this sort of bridges all three of these, from the truth, the logical extensions that are the heuristics, and then overall experience and wisdom in a problem. And the pro tips are the ones that we tend to give beginners. Beginners don't really know anything, so they can't really take on these big ideas. But you have to give them some tools, otherwise they won't be successful. They'll continue to make crazy mistakes. So it's better to give them something that they can use as a rule to go about the day-to-day. But if you're a beginner moving to intermediate, you have to be willing to let some of these go as you start to learn more sophisticated tools like the heuristics or the first principles. The very first principle, I consider that the computers run the code and humans read the code. So they're both talking about the same thing, the code that's written. And the code is written for the two different audiences. One is the computer that has to go through and execute line by line by line, and then the human beings that work on it and have to maintain it and write it and extend it and make sure that it's doing what the business needs it to do. So the code is the communication vehicle and the two completely different audiences. You know, the code that doesn't know anything about the domain that the code is trying to solve, doesn't know what the code is even doing, doesn't know the purpose of it, doesn't know what the variables' names are, it doesn't care. It just goes step by step by step through it. But all that information is super important to the people that have to maintain it, the new people that have to come on board and learn the project and be able to contribute to it. They need all that context. The computers don't. They just run it. You know, the humans have to read it. And you know, humans can execute code about as well as the computers can maintain it. Like they can kind of do it, but they're both terrible at the other person's job. You know, humans can't execute code very fast, and computers aren't very good, even with different AI of maintaining a code base. So here's a practical example. This code does the same thing. It's just the top one is kind of how the computer will view it. It just, okay, you want me to run function F? Okay, I'll just do it. But if you were to ask a human, like, what does this do? It can kind of tell you what it does, but not why or what the purpose of it is. So that's why we need additional context, like good variable names, good function names, and whatever documentation you can put in here. Make the code readable for your fellow developer. And from this first principle of computers run code and humans read code, we get things like these heuristics like KISS, keep it simple, stupid. Humans need to comprehend code in a certain way, so by keeping it simple, humans don't make as many mistakes, you get less bugs. And then another heuristic would be dry, do not repeat yourself. So avoid duplicating different logic, different ways in which you calculate numbers, or different code, so you're not having problems where if someone updates code over here, but there's also duplicate code over there, well, this isn't updated, so then it creates a bug. But these are also just heuristics. So if you have a good reason, you can violate these and say, well, in this particular example, we won't use dry here because, some other reason that you may have. So then, pro tips, which are extensions of heuristics, different tips like, use descriptive naming. This comes from the KISS principle, so always use clear, self-explanatory variable and function names. Comment on the code's intent. Make sure you explain why the code is doing what it's doing. It saves hours for debugging and making sure the other developers aren't confused working on it. Refactor ruthlessly to make sure things are modular. So when you keep things down into little modules, then junior developers and new developers can come on and understand what it does very, very easily. And use version control messages as signposts. Like the computer doesn't care about version control. It doesn't know. It doesn't care. It doesn't know, what the comments are, what the release version is. But those are really important to other human beings that have to work on this project. Okay, does anyone have any questions over first principles, heuristics, tips for this particular example? All right, so this definitely ran very fast. So I put in this slide to help out. So does anyone in the audience have any examples of rules in the software world that we use to develop that maybe we could try to classify them as first principles or heuristics or pro tips? Yeah.
Premature abstraction. So a computer's not going to care how many layers of interfaces and APIs you define. You can go 300 modules deep, and it's not going to care if it's going to connect to the back. It's going to get to the single curve back. And as a developer, if I have to go through 15 files to figure out how something works, I'm done. My context is done. So I think that's a big one that generally I say is like, yes, we should think about some extension in the future for making this work for future things, but trying to anticipate every possible use case of this in the next 10 years is going to be changing. That's the biggest one.
Good, yeah, next.
Along the same lines, over architecture, creating extensibility is important, but if you make everything extensible to the nth degree, you have created a monolith that is going to be too difficult to maintain.
Yeah.
It's dead on with what exactly the formal architecture is saying.
Good, next. Okay, good. Any other ones?
Optimizing without measuring.
Yeah, that's true. Like people will optimize code and then is it worse or is it better? No one knows. You spend all this time. Yeah, so that'd be another one. A first principle would be something about making sure you can measure. Otherwise you can't tell if what you did was any good or not. Okay, so this might be the fastest presentation of the conference, but that's okay. But I'll give you a summary here, and then maybe some action you can take away afterwards. Maybe you can think about it. First principles are the bedrock of software development. This is where all the clarity and all the wisdom that's come from many, many years now of software development through the decades, whether back in the moon landing or early systems all the way up to today, AI. These are the first principles that kind of build everything that we do and the approach we take. Humans read code, and this is really the most important. If you're writing your code and not thinking of the guy next to you or some person 10 years from now that you've never met having to maintain it, you should really stop and think like, okay, how is someone 10 years from now going to look at this that I wrote today and figure out what it does and why does it do it? And that person might be you 10 years from now, or it could be 20 years or 30 years from now. If you write something that's very successful, they live a long, long, long time. Someone who's not even born might have to maintain this code you're writing. Readable code saves all kinds of time and bugs, sanity, makes the team happier. People aren't so miserable all the time. And think about your code as having a conversation with other humans. It's not really, you're not monologuing with the CPU, but you're really trying to communicate with the other team, the other developers, other people at your company. And then finally, try to think about some different functions in your code base, and try to think about, oh, here's something that we wrote recently. Could a stranger read this and tell me what it did, even if they didn't know anything about this project? And maybe try to adopt a readability habit. Maybe the next time you write code, or the next time you're doing a pull, a PR, a pull request, and you're doing the review on it. Try to think like, oh, is this something a stranger might be able to understand, or is it so inside or so succinct that no one could possibly understand it tomorrow? And you can think about some of the rules that we have in software and try to think about, well, where does this first principle come from? What's really at the bottom of it all, or where are these heuristics coming from, or where are these tips coming from? And so that is what I have. We can have a few minutes here at the end for any questions you may have, or anything else that you'd like to add to anything that you might think about when it comes to these. There's surprisingly not as much conversation about first principles of software development, people tend to write these big books and these big volumes that talk more about, how it's done. They tend to be more like heuristics or tips. And they don't really get to the very, very bottom. This is what I found. Oh, go ahead. Yeah, so for beginners, they tend to give more like the tips and the rules and say, oh, when we write a service, we have, this type of structure to it, and we do it this way, and it's just easier if you do it that way. So a lot of times, when junior people will review a senior person's code, they'll be like, oh, we don't do it this way, but it's only because they understand these tips that we've given them, and they haven't quite got to maybe the intermediate part where we're talking more about higher concepts like these heuristics, where like sort of at every level you go, it kind of takes more experience in software development to understand how it works and how to apply, and but you got to start somewhere. So you start at the tips and you kind of move it through experience, and that's one of the reasons why so many senior people will put on their code reviews, looks good to me, and send it out, because it's just like, it's okay, it's okay. Yeah, that's a good point. That's why it always pays good to be a junior on a team of really senior people that understand these and are willing to help you out instead of just trying to get stuff done all the time and don't have time for it. Yeah.
One thing I want to bring up that I think would be interesting in this talk that we talked about, there are some bridges that we have in the software industry. So a good one, as a TypeScript dev, one of the biggest tools in the industry is specifically tools like this where you can have these tips, but the tips are actually integrated into the tooling such that when you're writing, you get that input swivel that tells you, hey, do this. And it's been especially useful, and I brought this to my team 3 years ago when I brought TypeScript recently, and you can click in and there will be a full leaking page that explains the rule, this is why you should do it, and then even to the point that you brought earlier, this is where you might want to bypass this if it doesn't make sense. So the happy medium is that it's somewhere between the computer and the human, where you're getting that automated part, but then also it's like, yes, this also is to help me compute and not make that mistake. So I think that's a reasonable middle ground in the process.
Yeah, and sort of an aside to that is there's almost always reasons to break any rule. So if your team is very rigid, then they're probably not understanding the whole kind of field here. The only things you can't break are, the first principle. So in this case, if you just wrote the most concise code you possibly can for the computer to run, 5 years from now, this project's going to grind to a halt because no one's going to know what's going on. So you'll always pay for that. But these other ones are, there's a little more wiggle room. All right, anything else? Any other questions? All right, well, thank you very much for coming.
Do you have any books, resources talking about this?
I don't. I stand 10 toes down. So I'm more like,
Next project later, right?
yeah, well, I try to just pay attention and think about things like, why are we doing it? I don't, just looking around, I didn't find a lot of like first principles, like books, or even, all these like academics that do all the stuff on the whiteboard. I didn't find a lot of stuff on that. So it's just, you find them and you kind of drill down and be like, oh, this sort of looks like this, or why do we do it that way? And you can continue asking why and drilling it down, and you'll find something down there as to like why we do it this way. There's always probably a good reason. So.
I personally like looking at code from open source software use. A lot of times they have to scale for so many people and so many use cases, generally good practices and then market. So that's what I like to do for something like
All right. All right, well, thank you, everybody. I did create a little game for super nerds out there. I call it the internet's greatest Easter egg hunt. So you can always scan this barcode. I left a few pieces of paper out in the lobby area, so if you can find one, you can start. It's kind of super nerdy, so if you like a little challenge, a little puzzle, you can start it. You'll sign up for a little email list, and they'll send you some hints, and yeah, I hope we can figure it out. All right, thank you, everybody.
post-lunch. All right, without any further ado. Okay. Good afternoon, everyone. I'm Akshay Mittal. I'm a software engineer at PayPal. I'm also a part-time PhD researcher. Before we begin, I want to share everything I'm sharing today is my personal research. It's nowhere related to PayPal or any other company whatsoever. Now, let me ask you, how many 2 a.m. production incidents has your team had this quarter? Please raise your hand. Good. And raise your hand if the production incidents keep you awake or on call. I've been there. I mean, it's always like back of your mind, you always have that, hey, I'm on call, something is going to happen, right? So today, I'm going to show you how we are moving beyond automation to something far more powerful, autonomous, intelligence that can think, act, reason and act based on like your best senior engineer out there, but never sleeps, right? So, and let me start with a big number, 44.5 billion. That's how companies will waste on cloud this year. But the real issue isn't just the money, it's the cloud system are too complex for people to manage their own teams. So I'm pretty sure everybody is working in some company over here. How many of you use, I'm pretty sure according to the research, 92% of all companies are in cloud today. And raise your hand if your team manages more than 50 services today, cloud services, okay? And have you guys had any production issue in last 30 days? It's very common, right? And typically, as per the research, production issues, based on the time they last to diagnose and do everything, it takes around 2 hours, right? Easily, like going through the logs, sniffing through the logs, understanding the issue, creating a hypothesis, trying a fix, trial and error, right? Depends, right? So the key statistics, right? As I mentioned, 92% operates in multi-cloud today, which creates like exponential complexity. On average, we're talking 1,300 services in an enterprise environment. To be exact, 1295, and 42% cite manual approvals are blocker, like basically a cognitive bottleneck. And companies who are having this issue report 100% revenue loss, right? The reality in the modern cloud environment is to generate more operational signals than the human can leverage or team can process, right? The bottleneck is not our tools, but it's the cognitive capability or capacity to make sense of how this exponential growing problems, right? Here is what really happening when we automate the doing, but not the thinking. So the cognitive overload challenge. The cloud adoption has been overwhelming, right? We have achieved unpredictable agility, cost efficiency, but the success has created a new class of problems than traditional, like simply that cannot be solved, right? If you look at this diagram, on top you can see a cognitive capacity growing linearly, which could create a complexity that grows exponentially. The gap isn't where the operational bottlenecks, but also manual intervention and revenue overhead. The bottleneck has been moved. It's all about execution speed, right? And cognitive load. We have more signals than we can process, right? More decisions than we can make, and more complexity a human team can manage, right? So how do we scale this operational intelligence without linearly or adding more team members in the team, right? This is a core modern challenge where DevOps, and it's why we fundamentally need a different approach. So one solution isn't like adding more team members to your team to solve problems, right? It's AI agents that can process unlimited scale and provide autonomous operations. So this brings us to a most significant IT operation that is in decade. So traditional AI ops, right? Traditional AI ops, as you can see, with what I called as only read-only mode. It's incredibly powerful at detecting anomalies and generating alerts, but it stops right there. The human is always a final executor, right? Look at the two workflow. The red one shows traditional AI ops. It ingests the data, detect anomalies, create alerts, recommend action, and human execute as an executor. Notice it stop at recommendation as probably a stage one if you want to do in a Gen AI fashion where you're chatting with ChatGPT, it suggests you something, right? Agentic AI ops is fundamentally different, right? At the green workflow, you show the agentic approach where it's ingesting the data, reason and analyze, it plans in a multi-step action, execute with guardrails, and learn from outcome, right? Notice the feedback loop is reasoning over there, right? It doesn't just observe and recommend, it reasons, plans, and execute, and also learn from previous action. So the human role shifts from an executor to a supervisor. So the new paradigm where AI becomes a true operational teammate. How many of you are using like Cursor, Copilot, Windsurf? Pretty much everybody, right? I use it in my day-to-day life for, like, I'm a developer, so pretty much on every task I'm able to use. Nowadays we started using for code reviews, writing tests, all the small things, right? And this is where, in the next slides, I'm going to talk about giving the small mundane tasks or repetitive tasks which are important, which cannot be avoided to these agents, right? So let me show you exactly how this is under the hood. To truly understand this AI ops, we need to see the architecture. This isn't just a single algorithm. It's a sophisticated system in a 5 distinct layers. Provided something might better for your use case, something might be replaceable. But like a Lego block, if you notice the diagram, first is perception layer, multi-model telemetry, just in CPU metrics, right? It's logs, traces, user sentiment, that too from support tickets, right? Even good or bad, both support tickets, and social media feeds, right? This agent sees everything, and which is passed on to reasoning engine, where the real magic happens. The LLM correlates signal throughout the entire stack. Query knowledge graphs the past incident and runbooks and move from correlation to cautionation, right? Moving on to planning system. The agent doesn't just suggest single action, it creates multiple steps with verification steps, right? With rollback procedures and risk assessment. I think most of you have seen like Copilot, Cursor. A lot of times when you interact with a specific model, they hallucinate a lot, right? The main system here is this agent should be able to plan it, reason it, and also kind of do that assessment and also provide a rollback mechanism if something goes wrong, because we are dealing with a production database, a production system here, right? Next is the action framework. This is an execution layer, like API integration with a cloud provider like Kubernetes controller, CI/CD platforms, but with critical guardrail, like such as human in loop control, like somebody is pressing a button, going through a governed process, so somebody approve it, because there should be a name to production when it goes live. The learning loop, where every action is logged, every outcome is analyzed. The system become more intelligent over the time, right? So this isn't just theoretical, right? The agent use a hybrid architecture combining transform-based LLMs for reasoning with specialized ML model for time scale analysis, all grounded in organizational context to a vector database, right? So the 5-layer approach, this 5-layer architecture is grounded with some real-world technologies and implementation pattern. While I haven't designed yet, as my research, I'm looking into it this end of the quarter to figure out some open source tech stack to be able to do it without taking too many permission from my employer. So I can discuss this practical approaches using Kubernetes, Prometheus, vector databases, and the best practices on my GitHub later. So anybody have built like any LLM powered operational tool here? Please raise your hand if that's awesome. So let me show you this in action with a real scenario. So imagine this scenario, it's 2 a.m., right? You're getting alerts about API latency spikes. Let me walk you through how agentic system handle this, right? As you can see in the workflow, multi-signal correlation, agent doesn't just see this high latency, it correlates the log showing database connection pools, the metrics showing memory pressures, and also traces showing the recent deployments. The next is the root cause hypothesis, right? It forms a hypothesis, the new deployment is causing memory leak, right? And leads to a connection pool exhaustion. Automated remediation plan. It creates a plan, scales the database connection pool, restart the affected parts, and monitor the fix. Now, human in loop comes into picture, right? For high-risk actions such as these, it requires a human approval, let's say via Teams or Slack, right? Execution and verification. It executes the plan, verifies the fixes, and logs everything for learning, right? So the goal isn't just to remove human, right? It's to handle these routine issues automatically while escalating the complex problems that require human judgment. So now let's look at how major cloud providers are approaching this. So this isn't just a niche trend, right? The tech giants, right? 3 major cloud providers are building their entire 2026 strategies around agentic AI. Let me show you their approaches. Starting with Amazon, Amazon Q Developer is positioned at if you're using Amazon, right? AWS as an AWS expert and collaborative teammate. The cloud control API, MCP server allow natural language to create infrastructure management. You can literally say, deploy this 3-layer web application with high availability. It literally transforms everything into cloud formation template. Microsoft, Azure, since using their integration to GitHub, Copilot has evolved from a pair programmer to an autonomous agent that can take an entire issues and deliver complete pull request. The Azure SRE agent provides always incident responses. Google approaches is little platform centric, if you will. They have their vector AI agents builder, which provides a unified workbench to create custom agents. Their AI orchestrated CI/CD pipeline make the entire delivery process adaptive and intelligent. So this isn't just a feature, it's a foundation of their strategies. your cloud strategy must align with your reality, with this reality, right? So the business impact is already like kind of measurable. So let's see some impact, right? Organization implementing agentic DevOps are seeing step change improvement across their every metric that matters. So 45% reduction in their lead time. AI agent automates a complex cognitive task like code reviews and risk analysis. 50% decrease in their production incidents. That is, predictive operation prevents issue before they impact the real users. 80% faster incident resolution, automated root cause analysis and remediation workflows. 30% improvement in the developer productivity, AI coding assistant like automated infrastructure management as such. 60% reduction in the cloud infrastructure cost. So continuous AI-driven optimization for their resource utilization. Faster time to market. Companies have noticed the 3.2 times faster time to market to translate their business outcome. One example I want to give is a financial company reduced their deployment time by 35% through AI-powered test selection. And a healthcare provider saw a 47% decrease through their predictive analysis. And these results are from real implementation, which are provided in the research I did. So let me show you one of the most advanced implementation in production. Thomson Reuters. I'm pretty sure everybody heard this name before. Thomson Reuters provide a compelling example of agentic AI at enterprise scale. They have implemented GitHub Copilot across their 10,000 plus engineers in a structured 7-week pilot program, demonstrating the AI assistant development in large organization. The pilot focused on agentic code reviews and automated testing, as in pilot. They measured the productivity using GitHub Analytics and developer service, creating a data-driven approach for AI adoption, that can enterprise basically from the GitHub universe, right? They have created a whole blog on this. And the results are amazing. 46% faster task completion, 39% improvement in code quality, 45% faster PR velocity. I mean, I'm always been there. Oh, here's my PR. We are already busy with our stories. It's hard to kind of review the PR, right? You need to take out time separately as a developer. Using this agent have really, really helped developer productivity and letting business get their stuff out there faster, right? 22.9 million in productivity saving, right? What's the most impressive isn't just the metrics, it's the cultural shift. Engineers initially, were skeptical about using AI, but I think it have become the strongest advocate. I mean, honestly, I use AI almost pretty much every day to write a script, write a documentation, getting syntax. Forget going to Stack Overflow for anything these days. Everything is within a couple of prompts, right? Let me ask you, how many of you in the audience are using AI agents at work or in general, or Gen AI in general? Okay, awesome. So now, how do you get started on this journey, right? So moving to, we have this 90 days roadmap. If a company, any scale want to move to agentic AI, right? Moving to agentic, it requires like a structured approach, right? Here is a proven 90-day roadmap, right? The first day 1 to 30, we start, assess and govern with, start with data. Data is key, right? Not antidotes, right? Identify your top 3 operational bottlenecks. Concurrently establish an AI governance console. That means a group of architects or who can set some rules for AI in cross-functional team that create rules for this AI agent, because this is very important step number 1. Day 31 to 60, pilot and learn. So deploy an AI coding assistant like GitHub Copilot or for a pilot team. Implement a agentic AI ops in read-only mode initially. I say read-only because you can see how it is providing you suggestion. Analyze that. Most importantly, invest in training like prompt engineering and AI supervision as a new skills. Day 60 to 90, automate and expand. Enable your first execution-ready agent with strict human-in-loop control. Analyze the result and build a data-driven business case for a broader rollout. So the key is starting small, right? Measuring the impact and building what works for you. Consider beginning simple developer productivity tool like that shows faster ROI and build momentum, right? As we conclude, let me share some key insight that should guide your strategy. So let me summarize into 7 key insights that helps in autonomous operation, right? Autonomy is a new automation. The conversation has fundamentally changed. We are moving from automating tasks to building autonomous system. So the industry is moving from read-only recommendation to execution-ready AI agents. I have experimented Cursor for my side projects and some thing. It was pretty good, right? You turn on the agentic mode, it was doing things for you, but sometimes it goes rogue and hallucinate and give me some bad data. So that is the reason if we go with a little bit more planning and providing those guardrails and constraint, it's always good. We have a rule, minimum, 2 people must review and we should back it up with a lot of testing, If something goes wrong in production, then it's gonna be bad, right? So govern before you automate, right? The power of autonomous system comes with responsibilities, right? Governance isn't just an afterthought. It's a prerequisite. So building a framework for trust and accountability is essential for this autonomous system. Platform engineering is enabler, right? AI agent does provide some intelligence, but it's the IDP, internal developer platform, that enables their practical and scalable use. A robust IDP integrates AI agent into the developer workflow. There are a lot of what we started is with a basic code review agents. I'm also working on so we have a lot of teammates coming. I'm creating an AI agent to onboard them. So with some chatbot kind of thing, So that's pretty cool. So we can also identify those small use cases, which helps really to get on board, right? The cloud provider are all in, right? This is just a trend. All the top companies out there, AWS, Azure, GCP, Oracle, Alibaba, right? Everybody are making their massive strategies, investment, and they're building into future around agentic AI. And I'm sure every of you have your favorite cloud provider out of these or something else. So definitely, right? So starting now, right? The transition is complex. It takes time because we might take some time, you might take a different time. So competitive advantage is for those who begin faster, right? Here is that action plan, what we discussed, which might help to identify your bottlenecks this week and maybe establish an AI console and start with a pilot project, right? Safety first, right? Autonomous doesn't mean unsupervised. Human in loop governance is non-negotiable for production system. We need to build a safety net into every autonomous decision we make. And multi-agent is future. By 2026, specialized AI agents will collaborate in workflow. Code gen agent, like security scan agent, deploy agent, monitoring agent, right? Start building this ecosystem now. So according to the research from MIT Technology Review and National ML, right? All this, what I'm telling today is backed up with some research I did. And if you have more questions, definitely I'm happy to chat more about it. So the organization that excel aren't necessarily that use the most advanced technology, right? But who can effectively integrate their AI into their culture, processes, and technology to deliver a better software faster. The future of DevOps is autonomous, and the time to start building it is
now. And thank you so much for your attention today. If I would love to connect with you all on LinkedIn. If feel free to scan the QR code, or if you have any, we do have time for around a minute for Q&A. Feel free to reach out if you want to discuss your agentic operation or ideas with me. Thank you again for your time.
This talk actually came out of back in March, we had a night of cloud at Dallas, and I had about 10 minutes to try and cover cloud, and I got through about a third of my presentation. So we represented it and brought it here. I'm a little curious, how many are in an on-prem to cloud, currently doing one? Okay, planning on doing one soon? Came in here because it sounded like a really cool topic. Hey, all right. I've been with CG Infinity for a while now. I've been working in the industry for the last 30 years. And this whole idea of migration and modernization, right? It's a great word, right? We've been using it for 30 years. We're always modernizing the next thing, right? We've been using these buzz terms. And when you start talking about going from on-prem to cloud, right, we're talking about taking that data center, taking those computers, and moving them up into the cloud. Or we're going from cloud to cloud, or we're going multi-cloud. We're doing a transition. And there's lots of justifications that as devs, we're like, why isn't everybody doing this? I mean, duh, right? It's seamless integration, grow as you go, shrink what you don't, fail over is seamless, you won't even notice. I mean, we've got these great buzz terms, but they only get about to middle management, and they never seem to bite the bullet. You can't get your CEO to pull the, we all know it's a great idea, why aren't they? Our leadership at CG Infinity actually put a document out about a week ago about this. When you're taught to speak, when you're taught to engage and interact, you're told to tell stories, right? That's how you keep your audience engaged. But the further you get up that leadership stack, the less they want to hear stories and the more they just want to see the numbers, right? They want to know, pay this, get that. Look, I don't need all the nitty gritty in the middle. And the biggest problem that we have when we're trying to evangelize this and get traction with this within our companies is we have great stories, but they're really hard to monetize. They're really hard to get a dollar number on that says, if you take this AWS, if you take this web API and you move it up into AWS, you'll get X amount of profit. How do you get there? So none of the migrations, none of the modernization projects that I've ever been involved with ever started from the dev evangelist finally convincing the CIO, right? Instead, it's always the CIO going, okay, our data center contract's running out in 6 months, so now we're going to migrate to the cloud. You've been telling us about the cloud, so now we're going to do it. The impotence comes from some sort of change, some sort of thing, and the big problem with that is every time they do that, there's always this like drop dead date, this deadline, right? Where the data center's contract ends in 6 months. Can you get us to cloud in 6 months? I guess. Well, if you can't do it now, we'll just sign another 10-year contract and we'll look back on it then. No, we're good. We'll get you there. Okay? When that happens, you do a lift and shift, right? You walk into your data center, you say, okay, how many servers do I have? How much capacity do I have? How much memory do I have? And you just take that whole big old thing and you put an identical copy of it up in the cloud and you copy all your, I mean, it's not even a dev thing. It's all in operations. They do it over a weekend and dev knows nothing about it. But then about 6 months later, they get that first bill. What? How much are we spending? I mean, this is more than the entire data center used to. This is more than, you just shot right past all of our budgets. This was supposed to be cheaper, y'all. You said this was going to be better. It was going to be faster. No. I mean, we've got big examples right now of companies that are rolling off the cloud. They're like, no, we're going back on-prem. It's cheaper. The problem is there's a difference between going to cloud and cloud native. Okay? Cloud native is when your applications and systems are designed to be on the cloud. You can modernize and just go to the cloud and get none of the benefits of the cloud. In fact, it'll cost you more. Chart of just some general layout, and we'll start going through some of this as we go along. But your lift and shift is your absolutely most expensive method of going to the cloud. It's the most expensive way to go from on-prem to cloud. The reason for that being, I said earlier that there have been lots of these modernization projects, right? We've been doing them for 30 years, but this one's different because how we're measuring it is different. For the last 30 years, the easiest way to solve a performance problem was more hardware. Just put more memory on it. Or wait 6 months. The new processor will be out and it'll solve the performance problem. Just keep throwing hardware at it. We've been able to stay up a lot of these old systems, stay alive simply on Moore's law, right? The computer systems double in size, the processing power doubles in size. It's still chugging along on a 1990s code base, but hey, we're good. Then we lift that monstrosity that we've created by throwing more and more and more hardware at it, and we lift that up and we put it on the cloud. Well, when you go to the cloud, let's see here. Let's skip ahead a little bit. When you're going for the cloud, you're paying for 3 things, okay? Your first one is data transfer. Every time you transfer data up or bring data down, you pay for it. Now, you never thought about that when you were designing an on-prem system. Data was free. The fact that I went to the server and did a query and went back and used it at the workstation on my desktop application, that's all, I mean, who worries about the line on the internet cable? But now we suddenly take our SQL server and go, okay, we're going to go to the cloud, so we're going to take it and we're going to re-platform our SQL server to Microsoft SQL, and we're just going to leave everything else just the way it is. Now all these things that we're talking to a local SQL database are now all going across the wire to get their data. And that bill just ching, 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 ching. Storage. When we were on-prem and we were building these things, it didn't matter, right? They were just hard drives, and you could just add more and more and more hard drives. I mean, we got these terabyte hard drive stacks, right? I mean, who cares? It's cheap. It's easy. The easiest way to solve the problem is just throw another hard drive at it. Hard drives are cheap. Now we go to the cloud, and we lift this monstrosity of data up that we're always expecting to be available in our SQL. It's all hot, it's all live, it's all the way over here on the most expensive layer because we just re-platformed our SQL up to the cloud, and it's all in hot storage. We re-platformed our file server up to the cloud. It's all in hot storage because we have no concept within our application of being asynchronous, no way to command and reply, no way to wait and get it later. If you built that in from scratch, I mean, you can use a whole lot cheaper file storage, but when you're just lifting and shifting, you can't. All right. For some reason, and I don't know why, but if there's one lesson I've learned in 30 years, big bang fails. The bigger that deployment's going to be, the more likely the thing is to fall off the rails. It just, but these lift and shifts, these cloud migrations, for some reason, they're all big bang. It's like we're going to take our application, and 6 months from now, we're going to go live on a, you're going to do what? Yeah, we're going to rewrite all. Big bang fails every time. I could use examples, but I'd probably get in trouble. A modernization, any modernization, needs a maturity cycle. You start with one thing. Get that one thing over. What's the quickest thing I can do? What's the easiest way? It may be a lift and shift. That's not bad, but you can't stop there. It might be simply re-platforming your SQL server. Again, not bad. Don't stop. What do you do next? What do you do next? It's a cycle of, okay, what do we have? How can I put that into a container? How can I move that container up to the web? How can I split that container up into smaller services so that it does smaller things and uses less memory, uses less hard drive space? And how do I go back around that cycle and find the next thing to move up and the next thing to move up? Because eventually we want to get to that far right-hand column, right? We want to get to that super cheap utilization of the cloud instead of the far left-hand column, the super expensive utilization of the cloud. We have to build that into our systems, but if we try to do it with a big bang, we're going to fail. So you find the hardest part in any of these modernizations that I've dealt with is coming up with that roadmap, coming up with that runway. How are we going to take small steps to eventually get us to that destination? And that's the trick in this. It's where do I want to go, and what are all the little itty-bitty weekly deployment steps I can do to keep my stuff in production to get me to that destination? That's, to me, one of the hardest things in systems engineering. Okay. So is that going up or down? That's going down. So first, any questions? Anything came up that has occurred to you that you're dealing with that I've touched on? Oh, great. Yeah, and I can definitely see that with an agentic or a predictive AI predicting what files I'm going to need so I can move them up in my storage stack before I actually make the request. I could definitely see an AI fitting right in there and helping in that area. Another thing on AI in all of this that goes hand in hand with this is all of these microservices, all of these, all right, first, macroservice, microservice, what's the difference? Everybody's got a different definition. Macroservice to me is something I lift and shifted. I just took my whole API, I wrapped it up on a container, and I put it up. That's a macro service. It does way too much. It does way more than we ever intended it to do. Microservice, we intentionally said we want to do this one thing well, and we do that. That's, to me, the difference between a macro and a micro. As we move these macro services up, as we move these microservices up, as we get into this age of agentic, as we get closer and closer to serverless, it's one of the newer things that's a driver in these modernizations right now, because these agentic AIs need these microservices. They need these serverless performance categories in order for them to be able to leverage activities. When you want your agentic AI to go do this little thing, you need something for that agentic AI to be able to call. So if you get to the point of having, hopefully serverless, but if not serverless, you know, containerized microservices, then you've got those available as we get into this era of agentic AI to eat those things up. So where do you start? Start with a lift and shift. It's where everybody seems to start. It's not where you have to start, but it just seems to be where everybody starts. You take your API, you take your database, right? Hopefully you're going to re-platform your database. Re-platforming is taking from Microsoft SQL to Azure SQL. It's not a big move, but there's some variances in there, and that's a re-platform, right? That's what I mean by a re-platform. Step one, lift and shift, because you're going to have to do that anyway. Step two, re-platform, right? Don't move your SQL server literally into a container and literally put it in the cloud. You could do that, I suppose. Re-platform it, right? Take that SQL server, take that MySQL server, and just use the built-in services on the cloud platform that you're looking at. That goes to re-platforming, right? We've got all of these different ways of re-platforming. Microsoft SQL to Azure SQL, MySQL to Amazon RDS. All of these are just taking a system that we are very familiar with and moving to an almost identical system up on the cloud. Your macro services, right? That's taking them, putting them into the containers, moving them up into the cloud, but using Kubernetes, getting aware of Docker, getting aware of, I swear I saw a guy that was hosting Windows 95 in a container, right? You can put anything in a container and put it up in the cloud. and then make lots and lots of them. And, yeah. Not saying you should, but you can, right? We went through a whole process of hosting PHP in containers so that we could reproduce the functionality within the PHP container. It was a trip. So how do I break that macro services, that big honking beast? How do I get that thing broken up? How do I get microservice chipped off of it, right? You got the strangle fig, right? Well, I assume we all know that one, right? Where you start replacing the inside, and it gradually, as you replace small components and pull them out and put them into microservices, it gradually just overcomes the whole form. It strangles the legacy system. It strangles the microservice gradually as you pull chunks of that code out into your microservices. Forked monolith, I've used this one quite a bit. You have two Git repos, okay? Well, you have your Git repo. It has your web API in it. It has your macro service in it. You fork it, and then you put both behind both Amazon and AWS have a API hosting platform that will allow you only to reach certain endpoints on certain systems. So now you have two different code bases, and the only difference between them is what endpoints this one exposes and what endpoints this one exposes. And now I just start deleting code. What don't I need in this one? What don't I need in this one to support those endpoints? And you just do a split monolith or a forked monolith. At that time. So, serverless containers. Right, we all know serverless isn't truly serverless. Serverless is just another way to say we don't deal with it, right? I don't have to manage the server. I don't have to get at the operating system. That's serverless. Because they're just containers, right? AWS and Microsoft are just spinning up containers and calling them serverless. But what does serverless give us? Serverless, how does it get us to that far right compared to being on the far left? Well, that's your compute. That's how you save your compute. Right now, if you have an on-prem server, or if you're using VMs in the cloud, you have to provision either one for 70% of your peak, right? You can't go back and say, what's the most memory I've ever used on this server? Okay, that's exactly how big the server's going to be. No, right? You're going to kill yourself. The rule of thumb has always basically been 70% of your peak. That way you've still got that 30% of growth room. Well, when you go to VMs, when you go to containers, if you provision all of that at that peak, you still have to provision at that size. That's still 70% of your peak. But serverless takes that away because it only runs when you need it to run. It's not sitting there occupying that CPU allocation all day long. You're not paying for it all day long. You're only paying for it when you need that functionality. Then the functionality spins up, then it executes, and then you move on. So we still have 5 minutes left, but if there are no questions. So yeah, so personally I find a lot of times these words get intermingled, right? You start talking about a refactor and an abstraction. I guess along some of those same lines on refactoring, I'm sure if you've been to any AI speech today, someone's told you that AI is built on data. You have to have good, clean data in order to be able to do AI. Well, now we're in an age where we're doing AI with code, And the biggest struggle I have when I'm starting to try to split up these macro services into microservices or take my microservices to serverless is the code itself. We've been charging up our tech debt for so long. It's not been a big deal, but now we're in there in these guts trying to pry these things apart, and we're trying to make, and now the quality of the code has suddenly become the key limiting factor on my ability to meet my deadline. I mean, it's always been there incidentally, but now it's come front and center. All these cool AI agents that are coming that are going to help us do all of these steps along the way, they all expect clean code. They expect to be able to read the code, work with the code, cut the code apart. If you've got a pile of spaghetti, no AI is going to be able to get in there and help you get that divided up. So if there's one thing to do right now to prep your way for AI, to prep your way for modernization in the future, it's clean code. Get the code cleaned up so that your AI agents can get in there and see it, read it, and work with it. Somebody else? All right, well, it's nearly the last session of the day, so not a lot of energy, and I understand. So thank you for coming.
Thank you. Thank you. Thanks everyone for coming for the session. For the next 20 minutes, I'm going to talk about what it means to be a developer in this day and age and how you can deliver value. And if you came to my session thinking there's going to be an AI talk track, it's not. I'm not going to talk about AI. I heard some dudes wrote an AI book. Just go buy their book. I think it's good. Well, this is me and my dog as Mid-Journey imagined us some 2 years back. Ever since I've kept it, it's quite funny. I'm a senior director. I've built multiple products. I've worked with multiple clients. I have a dog, and I recently wrote a book. So, how many of you are full stack developers here? Okay. I'm going to call you half stack at this point. Okay. You're half stack because full stack, according to the traditional way we define it, it's you do front end and you do a bit of back end and you're full stack. But what we don't talk about is nobody owns the deployment or nobody is there to do your deployment infrastructure integration. Unless you can do that, you're half stack for me, right? Because if you don't know how your code is going to run, how you are able to do automated deployments, you have not exactly built a production grade app yet, right? You need to know how your application is going to run, how your application is going to behave, how to investigate failures, how to recover from failures. You need to start thinking of those things too. That's when you become truly full stack. And if you look at it, right, and this comes from my experience, running all these teams, most of the time we spend trying to figure out why something failed. And I'm not even talking about production, right? Somebody wrote an app, we deployed it into dev or testing, and the QA is running it, and the developer doesn't know how to go figure it out why it failed, right? Maybe because there are not enough logs. Maybe the developer did not understand how the application is going to be built and packaged and deployed, right? So again, you're half stack if you're not getting into the deployment side. This is how I'm going to reimagine what full stack is going to be. I'm going to slap on the system integration side also to it, and that's going to include the integration, the deployment, and the infrastructure, right? Some of you all might be doing it, some of you are not going to do it, and from what I've seen, I'm going to tell you why some of you are hesitant to do it and how you can do it. Okay, that's going to be my talk. Great. So what's holding us back? I see there are 3 reasons. One is the fear. The fear of, you're usually used to IDEs and the autocompletes and other things, but when you're getting into the DevOps side of things, you're going to live your life on the terminal. So you are going to type in commands, you're going to hit enter, something's going to happen magically somewhere, and the terminal is going to come back. Maybe with some results before it, or maybe it's just an empty. Or if you are lucky like me, you're going to just do an rm minus rf on your slash and learn it the hard way. Okay. The other thing is a lot of what if scenarios, right? I mean, we as humans, we overthink it a lot. What if I break production? What if I do this? What if I do that? What if somebody finds out that I'm not great at Kubernetes, which I'm still not, and I still manage to deploy Kubernetes, right? Okay. I mean, these are all fine, but then when it comes to big organization, just in the name of security, there are a lot of walls. There are a lot of Chinese walls between departments. Oh, I need a server deployed, raise a ticket. But do we really have to do that in the lower environments, in the dev and the test environments? Not really. Recently, I've been working with a customer, and we had to get, we had to deploy something. I can't go into the specific details, and I was asked, do you have a Jira ticket for that? And I'm like, it's a dev environment. I need to deploy this. Give me access, I'll do it. No, you need a ticket for that. I'm like, that's not how it should work. I should have the freedom and the flexibility to just go do it. And this is something that I've built with all my teams, saying that you as a developer, if you're going to come into my team, you need to know how to deploy from scratch the application into a cluster. This is about, I'm going to give you a server, go SSH, go install Kubernetes, Docker, Kubernetes, run the YAML files, deploy the application, make sure it's working, right? And I'm going to quiz you on that. What that has helped me and my team over the time is I can just operate with a handful of developers. I'm talking about 10 to 12 developers, and we are able to handle production outages. We know where the issue is happening, and the only time we are actually waiting on, the resolutions to happen is for somebody from the customer end to come in on a call and get us our logs, because the walls exist. So how do you break out of these silos? How do you build these skills? 4 key things. 1, you need to learn to continuously build your code. Every commit should be such that you can build it. It should be automatically triggered. All the boring stuff you need to get out of the way, right? You need to learn to deploy it automatically. Run the script once, make it boring and reliable so that you can just run it and it just works, right? So you're not worried about how it's going to work. You can tweak a parameter and it should just work and give you the result. Third part is treat your infrastructure as disposable components, right? Do not rely on a server that you set up today to be available 5 years down the line with all the packages there. Just delete the server once in a while and see how quickly you can bring it up. Trust me, it's fun, right? Or just give it to a junior developer and ask them to just clean up the root volume. Anyway, finally, observability. You need to know what's happening with your system as and when it's happening, and not play Sherlock Holmes down the line trying to pick up the breadcrumbs and figure out who killed whom, right? No, you should know what your application is doing. You should be alerted when it's going up. When your CPU threshold hits 80%, you should be able to just go somewhere and see the logs and figure out what it is happening, rather than after the pod has died and then you are trying to figure out, oh, where are my logs? Right. Some of the tools that helps us over there, I'm not saying these are the complete tools. Some of the stuff that I've used personally, big proponent of Jenkins. I don't know why I still love Jenkins, even though it's built on Java. There is Argo CD, love Argo CD, Terraform, Ansible. I will not leave a single day without Terraform and Ansible. And then all the observability tools out there, Datadog, Prometheus, Grafana, some of the tools out there. Okay, so let's look at some of the examples. So how many of you here has built a Docker file and built a Docker? Okay, quite a few of you. So those of you who haven't done this side of the world, where you're not building code, and when you're talking about system integration DevOps, it's all text files. You can just read through the files and you can understand what it is, right? The Docker file here is an example. There are comments, but it just basically says use Node.js version 20. Working app directories should be / copy files, run something, copy something more, .. copy everything, expose it on port 3000, and then run the command node server.js. It's as simple as you read it. That's it. Everything on this side of the world is just configuration files, text files. Let's look at another one. Kubernetes, slightly more complex. You guys can see that? Okay, yes, say yes. Yes, you can read it. So, looks complex. That's a lazy man's JSON, because people don't want to put quotes into stuff and close it with brackets and whatever what they don't want to do. That's a YAML file. What it basically says, oh, I'm going to run MongoDB, and MongoDB is going to be hosted on image, or I'm going to use 6.0 version. Here are some command line parameters, expose this port, mount some files, give it this much CPU and memory, and that's it. That's how you read it. And it's going to run in some namespace, and the name of the app is Mongo. That's it. Another example, an Ansible playbook. So this is how you automate your software installations, right? I mean, you have a server running. What does it do? Find the machine, which is the Kubernetes machine, pull the Docker installer, run the Docker installer, set the permissions, reload the daemon, and restart Docker, or start the Docker container. That's it, set of files, right? It's just the syntax that's slightly different, right? And the way you do it is, you learn these files, okay? You memorize them so that you can just wake up any day and you can do it. No, I'm kidding, you don't memorize this stuff. I don't do this stuff. What I do instead is I build it once and then I templatize it so that I don't have to go Google and figure out how to do it again. So that's one sample YAML file that I always keep in some folder somewhere, where I know that if I have to deploy my image as a Kubernetes container, I just take that, anything that starts with -- is what I replace, and I deploy it. It just gives me some bare bones structure to start with. That gets me from nothing to a Kubernetes deployment in no time. I'm not worried about how much CPU I need, how much memory I need, how many replicas should I run it, nothing. For that, I hire the smart guy who can tell me how to do it, because I just have to get to that point at that point, right? So there you go. And then I repeat. So I got templates for everything that I showed you over here. I got templates for Dockerfile, I got templates for Kubernetes, Ansible playbook, Terraform scripts, everything, okay? So that's one way to start. Learn it once, do it properly the second time, and then templatize it, and then just forget about it, and then we'll worry about it later. Okay, so we covered that. So what are the best practices there? 4 key things. Security. We should always worry about security, about how we are building. Shifted left means that do it much early in your pipeline rather than after everything is done and then you're doing it as an end goal. With CI tools, you can actually do a quick scan of your code as part of your build process and tell you if a vulnerability is there. Make small changes. Don't do a big bang change for everything. Do small changes. Make it repeatable as part of your code. Build blueprints, as in like you templatize your infrastructure so that you can just take it to any system and do it, like the Ansible playbook that I showed you. It's the same installation if I have to do it again and again. Automate it, like most of you do, like me. If I have to do it a second time, I'm going to spend 10 hours automating it, even though that's the only time I'm going to do it. I'm still going to automate it. And then you build for observability. Okay, there should be a way in which you can find out what's happening behind the scenes, right? As simple as if you write a Node.js program and an Express app to expose a web server, a simple line that says listening on port 8080. It's valuable. That tells you that the server is running, rather than you run the command and it's just empty after that, right? An API comes in. One line that says, yes, received a post request, tells you more than just waiting, let's say 10 seconds to get the request. Maybe you don't know why that request is not there, right? So use logs, use observability to find out what's happening behind the scenes. Finally, to wrap up, 3 steps if you want to get started on this journey. One is you need to be really curious. Go look at your repository with the projects that you're working. There should be some pipeline file, some Docker file, some YAML file, something there. Just open it and read it, right? You don't have to understand it, just read it. You read it once, you read it the second time, and slowly you'll see that it just starts making sense step by step. You learn the fundamentals, right? You need to know what's happening behind the scene. That's a great link, roadmap, SH, DevOps, that gives you a nice way in which you can start your DevOps journey where all you can fit in. And finally, the next time an opportunity comes, just raise your hand and say, okay, I want to do it. I want to join the team. I don't know. I'm going to learn it that way. Okay? Very important. And finally, that's how you stop doing the writing code and you're going to give value. Okay? Now, let me just quickly show you what the DevOps pipeline looks like. So this is roadmap.sh. So when you're starting on the DevOps pipeline, language, learn an operating system. Don't learn Windows. Go down the Linux route. Okay. Nobody noticed the logo on my laptop, please. You need to master the terminal because you need to know your commands. Trust me, it's much faster than anything that you can do out there. Terminal beats UI hands down any day. Most of you would know Git. You're good there. Get to containers. Learn your networking protocols. Trust me, this is fun. Cloud providers, AWS, Azure, serverless, configuration management using Ansible, CI/CD pipelines using Jenkins or Circle CI, log management, secrets, and then it just gets a little more deeper into it. And trust me, the first time you build your Terraform script and you have an Ansible automated, you are never going back. You will never run that command again. I can see head shaking there because they know what I'm talking about. Okay? Now, the last fear that we have is that I do all of this, I would never be good at it, so why should I even start? Let me just leave you with one diagram over there. Just make it happen first, you can perfect it later. Just get started, right? Draw the roughest circle possible, do the roughest job first possible, then you perfect it, okay? And that's it. shameless plug for my book. Thank you. Thank you. We got 10 more minutes. Any questions? It's difficult. It starts by lending them a hand, saying that, hey, I'm here to help. That usually helps. And more often the Chinese wall is because they talk different languages and there is no mutual respect. For the DevOps, it's like, oh, you are asking me to deploy something, but you're not telling me how you want me to deploy it, and that's not documented. And then finally, the developer is asking the DevOps something, and they're treating the DevOps people as, you don't know how this app works, why are you asking me to do these things? You know, just get me the code or get me the log, okay? It starts with a mutual respect and then the willingness to, you know, understand each other and start working. That's where it usually breaks down. Yep. That's a lot of stuff. Yep. Easiest way is just follow the legend over here that anything with the purple is the recommended option, but I would suggest not going too deep into it. Just learn the hello world stuff. Understand it enough for you to make sense of how everything fits together. And then gradually as you build the skills, you'll know how it's all going to fit together, right? Instead of going deep into each and every item that's over here, start with the superficial knowledge, understanding of what that component is, and then diving deep into it. Okay. That usually works for me. Great question, bro. Yeah. I can. Done. Oh yeah, there you go. Okay. There you go. If that's all, thank you. Thanks for coming. Thanks for giving your time. Appreciate it.
Hey everybody, my name is Alex Merced, and what we're going to talk about today is about unifying data for data applications with the data lakehouse. So basically, by the end of this presentation, the hope is that we'll understand, one, what is the data lakehouse? Two, what are the sort of challenges with like modern sort of data applications, whether we're talking about building a BI dashboard, Agentic AI applications, what are the typical bottlenecks that we find in building some of those applications, okay? But before we get before we get down to all of that, let me introduce myself, if I push the right button. Now I think what did I do? Oh, I did push the right button. Oh, see what happened, quick fun story, is I lost my previous clicker. But see, this clicker is weird because it's vertical. So usually I think right, left, and, you hit right to go to the next slide, but up and down, not quite as intuitive. Okay, UX, good UX. Okay, but I'm Alex Merced, I'm the head of DevRel at Dremio. Basically, I've spent the last 4 years of my life basically talking about the data lakehouse. Okay, not talking about just what the data lakehouse is, but open source technologies around the data lakehouse, like Apache Iceberg, which I've written a book on, Apache Polaris, which I've also written a book on, and Apache Arrow, which I have not written a book on. But I've done that. I've basically spoken at many events, mostly in the data space. So I speak at like Data Day Texas most years, spoken at Data Council. I'll be at the Data Streaming Summit next week in San Francisco. I spend a lot of my life talking. But also, I was a software developer beforehand, and a lot of times I like to still like make fun stuff on the weekend. So like one weekend I was bored and created a document database in JavaScript just because why not? And that was SensioDB. So that's a thing. And I've written a couple books. So these 2 books you can get for free. Just scan this QR code and you can get those 2 books for free. Get a nice free PDF and you can learn all about some of the things that I'll talk about during this presentation in great depth. Okay, and literally we just released the complete manuscript of Apache Polaris Definitive Guide like yesterday. So that's right off the press. And then my 3rd book is what you see the stickers on the chairs. So if you're interested in the 3rd book, which I'm about 2 chapters away from finishing, that's that book there. Okay, so now, and then I'm raffling away a free copy. So again, this will send you up for a raffle to get a free copy of this book, because there is no free copy of that one right now. But I'll put those those QR codes back up at the end. And now let's kind of get on with our feature presentation. Now, what is a data application? Like, what is this thing that we're building? Like, what is this different than other applications? Okay, and since a data application is going to be one that basically is specifically interacting with data, whether it's for operational tasks, analytics, decision making. The idea is that we are focusing specifically on interacting with data that already exists versus creating new data or creating experiences for the user. Okay, this is an example like a BI dashboard. If you ever use something like a Tableau or a Power BI, applications that fuel that, or creating custom visualization applications, basically embedding analytics as like a dashboard in another application. Agentic AI systems, whether you're creating like a CLI to do like Claude Code, or you're creating like a chat interface, like ChatGPT's interface, whether you're creating any of these kinds of tools, they're going to be working with data. Okay, so you're creating an application on top of a variety of data. Okay, but bottom line is that when you're working with data, you're going to want low latency. You want to be able to get that data fast. You want to make sure you have, especially for a lot of like nowadays, you're talking about enterprise-wide analytics, where basically, hey, I want to join all my different departments' data to kind of get a full picture of the whole company. I'm going to want unified data, which is a lot harder than it looks, especially at bigger organizations, as I'll talk about in a little bit. And 3, well, we don't want to accidentally expose like the wrong information to the wrong people, so you want that data governed. Okay? And doing all of these things on growing amounts of data in growing amounts of places becomes more and more difficult every day. Okay? So, and again, nowadays our data is in, again, a bunch of different places, scattered across places like databases. So these are your transactional databases, where you're doing all your transactional type workloads, like adding a user, subtracting a user, adding an order, subtracting an order, or updating an order. These kinds of transactions where you do with like Postgres, MySQL, so forth. There's data warehouses. These are more optimized for analytics, where I'm saying, hey, give me the average purchase for every user in Nebraska. Okay, and asking more complicated questions where I'm taking every row and only taking a few columns of those rows and running analytics. It's optimized for those types of workloads. These are your Snowflakes, your Redshifts, your BigQueries, these types of systems. Then I have data in data lakes. What's a data lake? Well, a data lake is the idea that instead of actually having a system like a database or a data warehouse, how about we just store the data as files in like S3 or ADLS or whatever cloud object storage you prefer. And usually you would use formats like JSON, CSV, Parquet. You store the data there and you use tools, including tools like Dremio, to run analytics directly on those files where they're at. That's an option too. But now I have all this data stretched across all these different places, okay? And again, each of them has a unique way to access them. I have to set up separate access controls in them. So I'm creating users in Postgres saying, hey, they have access to this. I'm creating users in Snowflake, they have access to this. I'm creating different access control rules for my different users in S3, and S3 access policies are always a lot of fun, and so forth and so forth. It gets complicated really quickly, creating several different challenges. One, credential sprawl. The more different data sources I have, that's more credentials that are going to be in my application, which means more security issues, because if I forget to use the wrong environmental variable, or I committed to version control, oops, I've exposed chunks of my security. Okay, so ideally, the less credentials I have to expose in my code, the better. Okay, data silos. The data's in so many different places. You might have different software development teams in different departments of the company. And now I need access to this data that's part of another department. And now I have to put a request to them. Hey, can I get access to this database that you guys run? And now you're waiting like 2 months to get access to them because they have other things they're prioritizing, and that delays what you're trying to do. So your data gets basically siloed off for you to actually complete the projects you're trying to complete, which slows everything down. So it's not even just like the access, how fast you can pull the data, but just your ability to get access to the data in the first place. Okay, and then performance management. Okay, those actual queries, you want them to run fast. So normally we would manually do things like, materialized views, but then we have to do all this manual work to maintain those materialized views and make sure that they're in sync and refresh periodically. Or you might be doing BI cubes, or you're talking about like aggregations. There's all these different things we can do to optimize the performance of those queries. But again, at scale, it gets trickier and trickier and trickier. Okay, so let's talk about how we can move towards a direction, if you're building these kinds of data applications, that minimizes these problems. Okay, so first we're going to focus on minimizing the data access issue, the silos. So one of the patterns you're starting to see a lot today, the pattern that I'm spending all my time talking about, is the pattern of a data lakehouse. Now, in the world of a data lakehouse, what happens is you have this problem, where you have different departments in the company, and all of them, you end up with one of two scenarios. Either you have one central data team that manages all the data infrastructure for the whole company, but then what happens is that anytime any department needs anything, they have to go through that team, and now that team has been backed up with a bunch of requests all across the company, thus waiting a long time for those requests. The second scenario is each department creates their own data platform. Well, now one team is using Redshift, another team is using Snowflake, another team is using BigQuery. Problem is, those things don't all talk to each other very nicely, because they all store the data differently, they all work with the data differently, all optimized for their particular system. So now you're not just doing ETL, extract, transform, load, basically moving the data into the data warehouse. Now you're moving data between data warehouses, which requires you to write more code. You have to test that code, you got to deploy that code, you got to troubleshoot that code, and you have to pay to run that code. Okay, so you're increasing costs, increasing development time, increasing the time before you get the data, and things can still go wrong, which means the actual ending project might still be not perfect. Okay, and again, if you make bad decisions because you have bad data, well, now you're being counterproductive. Okay? So this is sort of like the world of today-ish and yesterday-ish. Okay? Well, what you're starting to see a lot of companies do, especially at the large enterprise level, but it's becoming more and more accessible down different size enterprises, is this platform of a lakehouse. The idea is, how about we don't put all of the data into a data warehouse? Because, again, then you end up with a situation where every team has like a different system that doesn't talk to each other. You have silos. What if we just standardize and say, hey, we're going to put the data in the same format that all these tools can talk to? Because the problem is, if you try to standardize and say, hey, we're all going to use the same tool, everyone has a preferred tool, right? So then you start getting into this political warfare saying, hey, no, we like Redshift, we like Snowflake, we like this. Okay, and then someone's going to win and it gets bitter and, not fun. What if everyone can keep using the tools they like, but they can work with the same copy of the data? Okay, we separate the storage and the format of the data from the tools you use to access the data. Okay, and that's what this lakehouse paradigm is. So the idea is the data will be stored as data files. So I mentioned earlier a file format called Parquet. Now Apache Parquet is really good for analytics because it's a binary format, which is going to be much smaller. It stores the data in a columnar format, which is going to be much better for compression, much better for analytics. So it's a very good, compressed, fast way to save the data. The problem is, Parquet files, they only know what's inside the file. They don't know about the other files. The problem is I might have a data set that's across like 1,000 or 100,000 files. So my sales table might be 100,000 Parquet files, and they don't know anything about each other. So this is why we want to wrap it in what's called a table format. which is a layer of other files, metadata files, that give context around, hey, these are the files that make up the table. This is the schema of this data set. This is the whole data set. And that's what we get, that's where the metadata files come into play. So we have data files, the Parquet files. We have an open table format that allows tools to see those Parquet files as a table, like in a database. And then we need a way to track those tables, a catalog. Now these are things we take for granted, because when we use a database or data warehouse, that just is part of how it works. Like you just go into Snowflake or you go into Postgres and it just knows what tables you have. How those tables are stored behind the scenes, you never think about. It just is. But in the data lakehouse world, all these things are broken apart, done separately. Okay, so I save the files, I have metadata around those files, and I have a catalog. But the beauty of it is, now, if one team is using AWS, they can connect their tooling in AWS, query those tables. Someone else is using Snowflake, they can query those tables. Someone else is using Microsoft, and they're using like Azure, they can query those tables without none of the data having to be moved or duplicated and all the costs that are associated with it. Okay? So that's what the lakehouse pattern is. It's essentially saying, let's all store the data in a uniform way so that way all my tools can talk to it. This is going to minimize your costs, save you time in having to share data between departments, because everyone can use it, prefer tools, but everyone can access the data without having to copy it. Okay, and then you're going to have much more consistent data across teams. So that's like the first step, okay, ideally. Like you move into a lakehouse, and now most of your data is now in a central format that any tool can access. Wonderful. You've broken down many of the silos, but you haven't broken down everything, because you don't have control over all data, right? Sometimes you get data from third parties. That might be in a third-party database or data warehouse. You might have some other files that, CSV dump that you dump from some platform you use. Like if you just dump files from well, now Salesforce has a way to natively do this, so you don't have to worry about that with Salesforce, but other tools will just dump you a bunch of CSV files. So before I get into solving that particular problem, let me just get a little bit more into that whole table format thing. So again, this is just a visual illustration so you can see what I mean by a table format. The idea is that I have these Parquet files, the data files. Right now, before we add the metadata layer, they're just files. Okay, so technically, to me, I know these 4 files are my sales data set. I know those 4 files are my orders table. But my tools don't know that, and they have no way of magically knowing that. But when I wrap them in metadata, okay, so now that metadata turns these groups of files into a table. Now, when my tool, something like a Dremio, Snowflake, whatever, goes and looks at the metadata, it knows, hey, this group of files is a sales table, this is the schema of the sales table, and now I can interact with it in the same way I could interact with a table that's in Postgres or in Snowflake, whatnot. Okay? It just basically changes the way my storage, so basically it can turn any storage system into a database, essentially, that any tool can talk to, which is really cool. Okay, I find it pretty cool, but I guess it's my job to. But I do find it cool, that's why I've been doing this for so long. Okay, so now getting back to basically solving the silo problem. So again, you have your lakehouse. So your lakehouse, again, is all that data stored in your object storage as like an iceberg table. So iceberg, just to clarify what iceberg is that metadata format. So while Parquet are the data files, iceberg is the metadata around those files that tells it, hey, these files are a table. Dremio is a platform that specifically is really built for iceberg. Like it's natively built to give a native iceberg experience. Most tools have iceberg support. Like you use Snowflake. Snowflake does Snowflake, but it also does iceberg. Most tools also do iceberg. We're like the one platform that's natively we were built specifically for that. But one of the things that we do that's going to answer the problem that you have with having all this data elsewhere is we also connect to anything else. We can connect to your Snowflake for all your other Snowflake tables. We can connect to Postgres. We can connect to on-prem data sets like a Hadoop or a Hive. So basically, instead of having to put all those different credentials in your application, so instead of your data application having connection, all this connection code for a Postgres database, for your data lake, your databases, your data warehouses, all this code, juggling all those credentials, you just connect them to Dremio, okay, or any other federation engine. So we're one of 2 federation engines. There's not 1,000 of them. But the idea is that we can federate your data, meaning you can connect different data sources, and now all of that, now you just connect to Dremio. And when you connect to Dremio, now you're only putting one set of credentials in your code, and that set of credentials only has access to what you gave it to. So it doesn't have access to all your Postgres tables. You can decide this set of credentials has access only to these Postgres tables, read or write, access to these iceberg tables, access to these Snowflake tables. So that way you can create credentials that are scoped to your particular application And then again, you can always just swap them out afterwards. So you only have one set of credentials you have to worry about putting in your code to a platform that acts as kind of a middleman. So that makes it, and also this makes the performance thing a lot easier. Because oftentimes when you're doing joins across different tools, what would happen is like, okay, I would go pull in this one data set from Postgres, and then I would load that up as like, let's say I would load it up as, let's say JavaScript as a JavaScript object, or an array of objects. And then I would load up this other data set from, let's say, MySQL, and I would load that up, and now I have these two arrays of objects in JavaScript memory that I'm then doing operations with in memory, which is going to be a much more heavy-duty way to do it. You're loading up much bigger objects into memory, doing operations that probably shouldn't be done there, because you're pulling the data from different places. Versus, you can actually have all that processing, all those queries, all those joins, all that stuff happen beforehand across these different data sets. You can design those in Dremio, and those get loaded up into a much more optimized format, much more performant, and then you're just getting the end result. So your code becomes a lot simpler because you're not doing all that joining across system in your code. You're just pulling the already pre-curated, pure, ready-to-go data sets. And Dremio has its own automated caching layer where automatically will cache things based on your query patterns. So in that case, all those materialized views you would have to manage, you don't have to do that anymore either. So your code gets a lot simpler and a lot more secure. So you can focus on building what is the experience that the user should have with the data, not focus having to spend so much time wrangling how do we access the data. So having a data lakehouse at all, having the data like Apache Iceberg tables, one, breaks silos across different tools, but then when you use a tool like Dremio, then it can help bring in the rest of your data that might be accessible to you as well. Okay, so the idea here, this makes building your application, and there is a open source community edition of Dremio that's free. So you could seriously just spin up a free container of Dremio, connect all your data sources there, and then build your application just using that as your sort of funnel for all your different data sources. Which is what a lot of customers do. They'll literally just go pull applications on top of them, and then a lot of people who use Dremio never realize they're using Dremio because it's an abstraction. It's abstracted away in the applications that are built on top of it. Okay. So again, we have zero ETL federation. So again, this is helping you unite your data because basically you can connect all your different data sources right through Dremio. A big thing with Agentic AI. So that's a big topic of conversation these days, right? Agentic AI. Because it's a really good application of AI. It's nice for me to be able to have a tool and say, hey, can you go look up all the customers and send them an email today? Okay, that's pretty practical, pretty useful. The problem is, LLMs, just because they have access to your data doesn't mean they understand your data. Okay? They know that you have an orders table, and they know you have this other table here, but they may not know which columns to join it on. It may not be obvious to it. So this is where a semantic layer comes in. Semantic layer, which could either be built into a product. There's other people who do like just a semantic layer that's just independent. Companies like Cube and AtScale. But what it is, it's a layer that provides additional context on those data sets so that when the LLM, your Agentic AI, is going in there and like figuring out, hey, what SQL should I write to send over, it's going to get the right SQL more of the time. It's going to be more deterministic because you've given it the information to do so. So we have that built in as a wiki, but again, there's also independent semantic layers that can be, like in Python, there's this new library called like boring semantic layer. There's companies again like AtScale and Cube. Dremio, we have one that's built in, but the idea is that you're going to want a semantic layer between the data and the LLM or your agent, because you want your agent pulling in those additional semantics on top of the data to have that additional context. So again, this is just another way that we help make it easier to build data applications by providing those semantic context for your AI use cases. Originally, semantic layers were built before Agentic AI. They were built because humans wouldn't know what to join data sets on. So the idea was, can I predefine a lot of these typical ways we're going to use the data as like views or something like that. And the funny thing is, like, most of the practices of good data stewardship that were good when we were trying to build the data directly for like other people to write SQL queries are just the same. They're just magnified now in the world of Agentic AI, because you have to imagine Agentic AI is a human with much less context than an individual. So you have to be extra careful about all these details because they're not going to have the context that an individual can make up for. Okay, I can maybe halfway do my modeling, halfway do my semantics, and then someone who understands the business enough can maybe fill in the gaps. But now, all these practices are same things we were doing before, but they're now just more important because we have to fill those gaps in for these AI tools. And again, real-time virtualization, just meaning that instead of having to make copies and copies of every possible data set, you can just join data sets in Dremio or any federation tool right there in the tool, and then have those definitions, and people will just query the views, And then again, it'll use its caching layer under the hood to make sure that the performance is good. Okay? And again, we have the whole minimizing credentials. So again, since Dremio is going to be handling all the credentials for your different sources, in that case, it's not in your code. And then you can programmatically access Dremio in any programming language, either through JDBC, ODBC, we have a REST API, and we also have a protocol called Apache Arrow Flight. Let me talk about that for a second, because that's something useful to know. It's another open standard. So there's another project called Apache Arrow. So remember I mentioned, like, hey, you know, the alternative is we do a lot of this juggling of data in our code. So if I'm doing it in JavaScript, I may be loading the data as, like, again, arrays of objects. And those are going to have a certain memory footprint, okay, which probably won't be optimal. There's a effort to create a universal way of representing data in memory called Apache Arrow. Actually, the project partially started at Dremio, or way back in the day when it started. So essentially, the idea is that this format is going to allow you to store a lot more data in memory in a lot smaller amount of space to operate on it. And it's all, like, optimized to make sure that even within the memory operations, you're not duplicating the data too much. So it's really fast because you're really optimizing how you represent the data in memory. But the problem is, what if you send the data to another computer, you send it over the network to some other piece of software? Sure, I've just processed the data really fast, but as soon as I use JDBC, ODBC, I have to turn the data back into rows, not columns, which means I have to spend all this time converting the data and then converting it again on the other side. So that project, the Apache Arrow project, realized, yeah, that's not a good idea. Let's create a new protocol that keeps the data in the same format as it travels. So you use this really fast format, and then you actually send the data via a protobuf in the same format, so that when it gets to the other side, there's no serialization. And there's a video you can find on YouTube where I actually compare, like, PyODBC versus Arrow Flight. With, like, 1,000 records, you're not going to notice a difference. It's just so few records. The time it takes to serialize and deserialize is nothing. But when you're talking about, like, 1 million records, when you start getting to really substantial amount of records, it makes a huge difference in the time that it takes you to, because the query might be really fast, but the time it takes you to actually process the data on the other end adds up when you're serializing that many records. So that's why we have that protocol. Nowadays, it's becoming an industry standard among data processing tools. So, like, Snowflake has an Arrow Flight endpoint, InfluxDB has an Arrow Flight endpoint. It's becoming more and more of a thing. And then they've created a whole new protocol called ADBC, that's like the JDBC for this kind of data. So it's a cool thing, okay? And again, I've written lots of stuff on this. So later on, I'll put the image for my podcast if you guys want to hear me talk more about all these things. I talk a lot. And again, basically, we're reducing risk of operational overhead, because the idea is, like, the more that a platform like Dremio can do in the data handling, then the less you do in your code. The less, now you're just, if you're building, like, a LangChain Agentic AI application, then all I have to do is really, like, nowadays we have, everyone's familiar with MCP at this point, right? I know when I was taking a look at the agenda, I was like, okay, there's a lot of MCP discussion here, good, okay? So bottom line is that MCP allows us to kind of create, like, little pockets of reusable AI functionality, okay? So in that, Dremio, of course, like everybody else, has built an MCP server. So basically nowadays, you build an agentic application, you just connect to Dremio's MCP server, and now your agent has access to all of Dremio's tools and semantics and all that without you having to build all that in there. And now, literally within minutes, you can have someone type in, what is my, actually I do this like every other week I do a workshop. Please register for a workshop so you can get hands-on with this stuff. It's a lot of fun. And you get to hear me talk more. These are the jokes. But what happens is that, again, it just becomes a lot easier to do a lot of stuff in the code because, again, Dremio is picking up a lot more of the work. And then, again, we provide tools like our MCP server that, again, makes connecting these things much easier. Okay? Again, we have this caching layer. It's called Reflections. It's really, really cool. I definitely don't have enough time to get too deep into it, but I could spend literally an hour just talking about this and how this works. It's essentially like a materialized view on steroids. So if you know how a materialized view works, and you know of all the problems with materialized views, like how to refresh them, having to tell people to update their queries, to use them, all these kinds of bottlenecks, we address all those things in a really interesting way. But I have done talks on that, so you can find those on YouTube, just for the sake of time. We have great optimization for like iceberg tables, because another thing about the lakehouse to keep in mind is that when you're saving your data on like S3 as tables, well, it's not like a database. Database under the hood, like Postgres, Snowflake, they are optimizing the data that you stored in there constantly. That's why the software is always running. That's why the database software is constantly running, because it's constantly optimizing. now you don't have that. Now it's just a bunch of files on a storage somewhere. So in this case, it's on you to kind of optimize the underlying storage of files and make sure that, hey, I don't have too many files with just like one record. We automatically optimize those files for you. So that way, that becomes a thing you don't have to think about. So then again, it starts feeling like using a data warehouse or a database again, because you're not thinking about those things. So it's an interesting architecture, but again, we try to take a lot of the edge. If you're doing a data lakehouse, we take a lot of the hard parts out by handling that part for you. Okay, but bringing it all together, theoretically, bringing it all together, you have Apache Iceberg that allows you to standardize data on the lake so that we have one place that has your data that all your different departments can work in. So if all your departments kind of standardize and saying, hey, we're going to use whatever tool we want, but we're going to end up making a copy of the data in Iceberg, then you minimize the replication of data that happens down the road. Okay? If you use Dremio, you can then bring in your other data sets without having to do additional data copies. And again, that can be the center that stores all your credentials, becomes the sort of the thing that kind of obfuscates a lot of the stuff you don't necessarily want to be doing in your code and handling it there. The result is you get a faster, simpler, and again, Dremio also handles access controls because your Dremio credentials that you give to that whatever application you're building, well, you can control what it has access to. So you now have fast, governed access to all your data. So the result is something that looks like this, where you have all your data sets, databases, data lakes, data warehouses. They would all connect to Dremio, and your application would just focus on connecting to Dremio and basically having a very simple life. Because basically you just have one connection in your code, you just send all your queries to that one connection, and then you worry about the rest of the functionality of your application. And again, stuff you can try it at home. There's a free community edition with a Docker container. I play with it all the time. Got lots of videos on YouTube where I show how to spin that up real quickly and try this stuff out firsthand. I also do a podcast where I talk a lot. So if you want to subscribe to that, that's Data Nation. You can find it on your favorite podcast place. You can find links to everything I have over there at alexmerced.com. So if you know my name, you know where to find me. alexmerced.com. Okay, so keep all the cameras out because I got a few more QR codes as we wrap up. Okay. Also, this blog is a more detailed blog that goes over this whole ecosystem. So if you want to get a deeper dive into this whole data lakehouse ecosystem, as a whole, read this blog. I just posted it 2 days ago, but it's a real deep dive through the whole thing. So by the end of the time you read through it, you will have caught up on everything that took me the last 4 years to understand. Okay, so I'm giving you 4 years on a platter in a half-hour read. Okay, this is the raffle for this book. So basically, the winner will get an email from me with a coupon code, where you can get a free copy of this book. This is my 3rd book that I'm currently writing. Yeah, it's been a long year. Oh, Thursday. Now, quick tip: if you're doing public speaking, see that trick I just did there, where I just said, "Oh, Thursday." That could be any day. It doesn't matter what day it is, because we've all had that Thursday, that Monday, that Tuesday, that whatnot. So it just breaks up the tension because everyone's like, yeah, no, I know I've had a Thursday like that. But really, it works on any day. So, fun trick. And again, here's where you can get the free books. And there's a bunch of other links there. So actually, there's links to articles that'll show tutorials where you can try this stuff hands-on on your laptop just using Docker Compose. Also, there's some video tutorials there as well, so you can see the stuff in action. So everything you need is going to be in that QR code. And the list that I created on GitHub. And with that, that's the end of my slides. One, thank you guys sticking for me, because I know it's the end of the day, and so I appreciate you guys crossing the finish line with me. My name is Alex Merced, head of DevRel at Dremio. Thank you very much. Have a wonderful day. Oh, where am I doing? Oh, and add me on LinkedIn if you have any questions. Just contact me on LinkedIn or whatever. Cool. What's that? Cool.